All right. Perfect team. So I'm not sure again if anyone has any questions in particular about what we've been seeing so far, or anything before we start with our session today. All right. Seems like we're good. So Hitesh, not sure if you have anything for the team before we start up maybe with a couple of activities.
You mean Kahoot activity?
No. Just wanted to check if you have
Oh,
anything
no,
before we
no,
start
nothing from my
with the
side.
activity.
Yeah,
Okay. Cool,
yeah,
cool. Yeah, no, I got the Kahoot. Most
sure,
likely we'll be doing it either later today or tomorrow. But yeah, I got it there.
sure.
Cool. All right. So, guys, does anyone remember what was the way that the tunnel local proxy was intercepting the traffic, and where is that specifically relevant, or that we need to check onto that? Let me see. Samira, how are you?
Hi, I'm good.
Hey,
Oh,
glad to hear that. Excellent. So, do you remember what was the tunnel local proxy doing in the client connector? Was there something specific that we need to keep in mind?
you mean the back file or
Yeah, in general, yeah. How does the client connector intercepts the traffic when we're using tunnel local proxy?
it would be forward to CCC?
Yep. Yeah, well, yeah, we need to intercept the traffic and send it to CCC. And you know that depending on the options, you may, or the client connector might be doing that in different ways, right? For
Yeah.
example, when we're talking about tunnel 1.0 with route-based, the client connector will receive the traffic, right? But will receive the traffic because there are some routes being installed, correct?
Yeah.
So in the case of tunnel with local proxy, what is the client connector doing to send or to intercept the traffic from the browser?
Mm, not sure.
Anybody that would like to help out also, or add up to the conversation here? Let me
Believe this
see.
situation is setting the default gateway.
Well, we're talking about the tunnel with local proxy, right? So, in the case of that specific traffic forwarding mechanism, what is the client connector intercepting? 80 and 443 or HTTP and HTTPS?
Oh, it's HTTP and HTTPS.
All right. So, how is that we are intercepting that web traffic?
Uh,
We're not
set
doing
up
it
the
with routes,
proxy,
right?
set up the proxy setting on the user device.
All right. Yeah, we set up the proxy settings on the client's machine, right? And where is that proxy pointing at? Sorry, come again?
To the local host?
Exactly. It's to the local host in the listener proxy port of the client connector. Remember the tunnel with 127.0.0.1 with port 9000, right?
1 minute, one small question. Like, can we change the port instead of 9000 to the custom port?
That is correct. We can customize that. That's a configuration available on the mobile portal. We actually saw it yesterday. And it's a customizable port because there are some applications that are using that same port, right?
Yeah, so because of that application, if that 9000 port consumes by some other application, we should go for some other port, right? Instead of 9000.
Correct.
Yeah.
Correct, correct. But yeah, but we can customize that if we need. Just by default, we use that one too. Um, but yeah, that's how the client connector is going to be trying to intercept the traffic from the browser in this case, and put it into a tunnel where the traffic will be then sent to an SME for policy enforcement. Now, anyone recalls what's the difference between this tunnel with local proxy versus the enforced proxy that we saw on the first example yesterday? Let's
The
see.
enforce proxy, we configure the pack file which is needed, and authentication will be there. So compared to tunnel with local proxy, yeah.
Okay, so sorry, where will be the authentication?
I think browser authentication will be there, right? With the tunnel, tunnel with enforce proxy.
That is correct. That is correct. So yeah, we use the browser-based authentication, which is using cookies, right? And when we're using tunnel with local proxy, the cookies are no longer necessary because we're using the digest authentication of the client connector tunnel. That's why when I was having tunnel with local proxy setup, you can open up an incognito window and still send the traffic through Zscaler, right? And still identified as your user. Make sense? Let's recap on that part before we jump into tunnel 2.0. So once again, here is just a quick summary of what we saw yesterday with tunnel 1.0. We are going to be sending the traffic either from the application, either browser or any other application. And if the traffic is proxy aware, we are going to be intercepting the traffic by sending it to that listener proxy port. Remember, guys, this is on the slides that were shared yesterday on chat. Also, I sent them on the email. If anyone needs them again or doesn't have them handy and needs them right now, let me know. I can put them on the chat again, okay? So then if the traffic is not proxy aware, then we're intercepting the traffic with other options, like in the case of tunnel 1.0 with lightweight filter or tap driver. Also, tunnel 2.0 uses the lightweight filter to intercept 80 and 443 or approach protocols in the case of tunnel 2. We'll be seeing tunnel 2 in just a moment. And the app profile pack that allows us to have certain actions. What certain actions can we have with this app profile? Let me see, Survey, any idea? Shivam, let me see, or Survey Jadav there? Might be double muted.
Yeah, Des, can you repeat the question again?
All right, all right. So yeah, what's the kind of things that we can do with the app profile pack? And why don't we just send the traffic here, right? What does this add as a benefit to here? And what can we do with this?
Well, mostly we can direct the flow of the traffic by mentioning what traffic has to go through proxy and which one is internet traffic.
All right, all right. Yeah, mainly that traffic manipulation, definitely that'll be the main topic there, right? One is that one, managing bypasses and what goes into the cloud. And beyond that, what can we do with the traffic that's going to the cloud? Any other flexibility or options that we may have with the pack files?
Well, we can give multiple, what do you call it? So you can mention multiple proxies in it.
All right. Yeah, we have failover capabilities. We also have the option to send to, for example, a virtual service edge. If there are some applications that are source IP restrictive, we may send just that traffic to the vSAN while the rest of the traffic is going to the SAN, right? Also, which SAN is going to be a big option that we can have with these kind of profiles with the help of the country variable and the country gateway variable. Well, the country gateway variable and the gateway variable, sorry. Those are allowing us for the client to get to the closest data center available without having to manage multiple pack files and having to maintain that manually. So, yep, those kind of things, load balancing, having connection to the closest node, and overall traffic management and manipulation in general, right?
And apart from that, the one other thing which I noticed when I actually worked with the pack files in Zscaler is that you have programmable option like if and else case you can mention that, okay, if this traffic is specifically for this, then use this proxy, else use that proxy kind of scenarios I found to be unique. I mean, I haven't worked with a lot of pack files because most of the pack files I've worked in my career are pretty straightforward ones. But with Zscaler, you get more options to work with.
Got it. Yeah, it at least allows you to use it as much as you can as you want, right? So yeah, that's a good thing, but that's also sometimes quite dangerous, right? If we don't do that carefully or we don't do that with certain type of baseline or order, eventually troubleshooting that a year, 2 years later after deployments, it's when things can start getting a little bit complicated, right? Sometimes even sooner.
Can I ask a general question, if that's okay?
Sure, go for it. Sure.
Okay. In the past, I have come across scenarios where the pack file has trouble distinguishing and declaring the traffic being SSL or HTTPS. I've come across this scenario while I was troubleshooting an issue in the past. Is there a specific, I don't know, attribute or something that we need to put in that differentiates SSL traffic and HTTPS traffic?
Not really, because that's actually not a job for the pack file itself, right? What the pack file is looking for, it's the URL or the host name on the browser, right? It's not even working at that level to look for the protocol itself. I think it might be more of a browser thing. Um, because as you know, right, some browsers start using quick protocol where start using UDP connections and stuff like that. I'm wondering if that might be something like that that could be causing those kind of problems, or I've
No,
seen also
the reason why I
situations.
asked, sorry about that. So
Yeah,
the
go ahead.
reason why I asked that question is because recently we had that issue, and the fix for that was to create a entry in the pack file for that specific internal web portal so that it was forwarded as an SSL traffic instead of a HTTPS request traffic.
But that's where I'm not fully understanding what's the use case there. So the situation is that on the web insights for CIA, you are seeing it as HTTPS and it should have been SSL, right?
Yeah, it forwards for the SSL inspection basically.
Yeah, exactly. So we were doing SSL inspection and we needed SSL bypassed, right?
Yes.
All right. So the policies for SSL inspection, what was you had an explicit policy bypassing that traffic, right?
Yeah, so basically we had a policy that basically said that it has to be an SSL traffic so that it goes through the SSL inspection and it goes to the CPA to go to the ZPA, which is there in that environment, to be forwarded to a client environment, a secure environment. But because the traffic was not getting categorized as SSL, it was getting dropped as a normal HTTPS request traffic on the ZIA.
Okay, let me see if I get the whole idea here, because it's the whole issue, it's a SIPA issue, right? For what I'm understanding, correct? So we have a client, we have the CIA service edge, and we have the CPA environment where it's slash SIPA, right?
Correct.
So the issue here is that the customer is trying to go to a application,
Yes,
and
internal
that
application.
application it's going over the service edge and basically trying to go over the internet. It wasn't taking the SIPA rule, right?
Correct.
Okay, and that was because the criteria for the rule is that the traffic on the protocol has to be SSL, correct?
Yep.
And the traffic was forced to be SSL inspected. So I have a couple of questions with what was the criteria for the SSL bypass rule, and also why was the criteria to be protocol SSL? Was it all protocol SSL, or was it protocol SSL plus something else like a category or something like that?
Basically, when I look at the analysis, web inspection, web inspect logs, the traffic showed that it is a HTTPS traffic instead of an SSL traffic. And when it was, whenever it triggered the SSL inspection, the traffic would go to the SIPA. When it is not SSL, it wasn't going there. And they had like 3-4, what do you call it? Load balanced the internet IP addresses, and only for one it was failing. So once we added that IP into the pack file, it started working, and it started being shown as SSL.
That's interesting. I've never seen. I would like to know a little more about what was the criteria on the policies, because that's initially what will dictate if the traffic is inspected or not, right? It's the SSL rule, right? So I'll like to see a little more of what was the policy on that case and what was the order of that policy, right? That along with the logs might give us a little bit more perspectives as for why, although it might not tell us the whole story, right? So the issue was fixed after you added the IP address into a pack file, meaning that the traffic was going through the client's connection, correct?
Yes.
So the traffic was previously bypassed from the client, but was still seen on CIA, which tells me that something else was intercepting that traffic, correct?
Can you repeat that again?
Yeah, the issue was fixed after on the pack file we added that traffic, right? So
Basically,
yeah. So previous to that, the traffic was as not just SSL bypassed, but was completely bypassed from the CCC tunnel if that client was having a CCC, correct?
Yes.
So that means that something else was putting that traffic back onto the CIA service edge, most likely a tunneling mechanism. So that might be part of the whole situation. If the criteria was the user, then we might see why it was not basically triggering the SSL policy. But at the end of the day, also, it's basically what's the criteria on that policy, right? Because that's what will dictate if the traffic is inspected or not. That's what I like to see a little more of. And what is it that we're seeing on the logs? Because it should be coming as part of the user or as part of a known location.
All right. I mean, we can circle back on this. Once I log
Sure.
into my office laptop, I can pull out the details and share it with you. We can, discuss this.
Sure. Yeah. Absolutely. And actually, the more we go into CIA in general, the more we'll see about how to approach these kind of things, right? Because it's like as you're seeing, right? We're talking about SIPA, SSL inspection, and also at the end of the day, user authentication as well. So we may need to first narrow down little pieces of that or do some sort of isolation to kind of like make sure that we're looking on the right place, right? Because we're talking about SSL inspection, but the issue was fixed after we applied something in traffic forwarding, right? So that's where I like to see a little bit more of where the actual issue might be here. Cool. Excellent. But yeah, feel free to share a little more on that part. I'll definitely look forward to see I'll see a little bit more of that use case. We might be able to even try to reproduce something like that from here.
Yeah, I'll have a word with my colleagues and try to get more info on it and share it across. But I don't want to, kind of hijack the whole session. That's why I was like, okay, let's cycle back on that later.
Cool. Yeah, absolutely. All right.
Yeah. So Davis, I have a question. So can we create a custom pack file when we are using system with local proxy?
Yes, because there are two pack files, right? When we're working in ton of a local proxy, it's the system proxy that uses a pack file, right? And
Okay.
then there's the app profile pack file. So usually all the customizations will go here. This is mainly just to send the traffic to the client connector. You may
Okay.
apply certain bypasses here if you want, but usually overall traffic manipulation will happen here.
Okay. So can you show us in the in the platform that where we are going to create exceptions in case when we are having a custom pack file for tunnel with local proxy, the system
Sure
proxy.
thing. Yeah, let's do a quick demo on that part. Let's get here on the client's machine. 1 sec. See. All right, so I'm on Zscaler 3. I'm test user CCC, right? So we are currently using tunnel 1.0. Let's take a look at what is the current policy here. Baby's app profile. Let's see. Also, let me do one thing here. Oh wow, Zscaler 2 is so slow. Sorry guys. Let's see. If not, we might play with this one then. Because it seems like this one it's currently connected. Yep. I end up doing that. So let me log out of here. And let's change this Okta 1 profile. The profile here is bootcamp. So let's play with this here. So this profile will be tunnel local proxy, right? And we'll have this option. So with this configuration, what we're doing is that we're basically saying that these proxy settings will be enforced, or this will be enforced in some proxy settings, right? Those proxy settings will be the ones that we are seeing in this part over here. Okay. Now this pack file is created by default. We don't have to create it or anything. It's basically a transparent pack file that will just redirect the traffic here. We may create one, but we'll just take a look at it once we save that. The one that we'll be mainly looking for, it's the app profile pack. Okay.
Got it. Got
So
it, Davis. Yeah. Thank you.
okay. So let me save this. And also, let's go back to the app profile. Now, right now, if we take a look at the app profile, there is no custom pack URL, right? So it will basically follow the same behavior as Gateway. It will just look for the closest data center available, but there is no pack file here that will bypass any kind of traffic. So let's take a look at some of the pack files that we have in here. Let's see this one, for example. This one is sending traffic to a specific BIP. Here are a few others. Let me see, SME pack, practice. Let's see this one where it's sending traffic. All right, let's see. This one is sending traffic to a specific data center here, right? Now, let's use that pack file. This is the one called practice, right? And you'll see also how misconfigurations here may eventually give us some issues with the client connector as well that we may need to look for. So this is the pack file or the pack URL, right? And I'm just gonna save that. Now let me just log in here as that user. Right. All right. So you see that it's showing the host name that I configured on the pack file, right?
Correct.
So if I change this to, I don't know, let's use any other one because actually this is misconfigured. If I try to browse this, I don't know if you guys noticed, but this is actually from a different cloud. You see, it's trying to connect to an SME on Zscaler 3 while using credentials from Zscaler 2. So I'm not even really sure why or how is this showing connected. There it goes. Now it's giving me some errors, right? Just because I'm pointing to the wrong place.
Got it.
Let's
And
change
and
this.
and can you show me
Uh-huh.
the local system proxy? Is it still pointing to port 9000 or some different means what customized port that we have
It's
here?
pointing to a customized port if I'm not wrong.
Yeah,
Let's take a look.
8888.
If I'm not wrong, that's the one that I'm using right now. Let me show you here. No, this is using 9000 because this is
9000.
another cloud. Yeah,
Okay.
because the 888, it's on my Zscaler 3 cloud. This one, I think it does still have dates. Yeah, it does
9000.
have the 9000 on Zscaler 2.
Got it. Got it. Yeah. Thank you. Thanks, Davis, for just the explanation. And Davis, I do have another question. Since the tunnel uh, uh, 1 is used to forward port 80 and 443 or HTTP and HTTPS to the Zen enforcement node. Okay. So I'm keen to know that if I'm just typing google.com and having ZCC with tunnel 1.0 configured, how the DNS traffic is routed towards the cloud because it's
Well, in those cases, it's not, right?
okay.
We'll need to have other mechanisms also in place, right? Because
Mhm.
now this is where tunnel 2 comes into place. Right now, if we have a DNS, it's most likely a local server, right? So that's the first thing, making sure that we're maybe forwarding that to the actual cloud or to the internet so it can go over CIA, right? That's one main thing, because otherwise, if the DNS is local here, even if the tunnel is here, all traffic will be resolved here, and then I'm sending the web traffic through there. In those cases, no DNS traffic is seen ever on CIA, right?
Okay. That means it's
So yeah,
locally resolved.
it's locally resolving, and then the web traffic, it's the one going out.
Okay, got it.
So we either need to have that intercepted at other levels, pointing out to the outside, or in the case of tunnel 2.0, we're usually going to be trying to intercept all DNS traffic with the help of the inclusions for the 53 port, or port 53.
Got it, Davis. So another question, maybe it's means maybe we are going to study in some other next coming classes. So just take an example that I am using ztunnel 2.0, correct? And I am having both the service enabled, ZIA and ZPA. Okay, I'm just typing any random website. So how come my ZCC comes to know that this traffic is for enterprise, or it should be going via the ZPA?
Yep.
And
Well,
and where
the thing is that sorry, go ahead, finish it.
yeah,
I'm sorry.
I'm just means a bit confused with this packet flow, how the DNS is going to resolve that. Which tenant is going to means give the DNS resolution? Is it the ZIA, ZPA? Then based on that, how they come to know that this is external hosted, and based on the policies, it's going via the ZIA. And if there is any website that is internally resolved, then how come the ZCC knows that where I need to point this URL or traffic to?
Yep. Well, the main thing here is that when we're talking about the CPA service, we are specifying always the applications that we're going to be actually intercepting. So let me show you here real quick, just to give you a quick sneak peek of my CPA portal, for example, right? So let me show you here. All right. For example, here I have this is a CPA portal, right? So when you have CPA, you configure different application segments. Like in this case, for example, I have a few applications, like this one that's called myweb.local, right? So myweb.local is something that when the client on CPA, let me put it this way, the client here is going to be connecting to CPA and to CIA, right?
Correct.
So when it downloads this configuration, it has the proxy settings to intercept all the web traffic and everything like that, right? But at the same time, it's getting here the list of all these applications, and it
Okay.
will create specific lightweight filters for those hosts.
Got it.
So now
Got it.
when I try to resolve something like this, it will resolve to a synthetic IP, allowing me to put it in this tunnel instead of this tunnel.
Got it. So means all the informations are already our ZPP already knows, the connector already knows that which traffic it needs to send to ZPA. Got it.
Yeah.
So
We
what in
basically
case,
give them the list of apps
yeah,
that they
list of
need.
details. So what if in case I'm using a wildcard mask for any application? I'm very much new to the infra and I just opened a wildcard mask. So in this case, is it going to forward all the, what to say, the traffic? Because a wildcard is a
Yeah,
wildcard
yeah.
and we don't know that what request is
Yeah,
going to
it
be discovered from
follows
infra. Yeah.
it follows a wildcard, and it basically start giving you a report of the discovered applications. Yeah, that's more of a CPA part of things. Yeah, but yeah, it's basically allowing you to discover what applications you have in your environment. That actually it's very common when customers are starting with CPA, because they may have very old applications that they didn't even know actually still existed, or they're still being used or stuff like that.
Got it.
So this is very, very good for that. And the dashboard itself for CPA eventually tells you what were the discovered applications within the last 2 weeks and stuff like that, allowing you to then create your own apps and take
Specific
it forward.
application. Yeah. Thank you.
Yeah.
Thanks, David. Got it.
Sure. All right. So, team, let's talk about Tunnel 2.0. Now that we have a more clear understanding of what Tunnel 1 is doing, we'll go into Tunnel 2. Why? Because Tunnel 2 is backwards compatible with Tunnel 1. And we actually going to be needing Tunnel 1 for certain type of use cases. So we'll talk about that here in just a moment. So with Tunnel 2, we can intercept all the ports and protocols without affecting the CPA tunnels at all. It creates two tunnel, a data and a control channel. And it once again allows us to intercept all ports and protocols. Couple of differences between Tunnel 2 and Tunnel 1. Remember that with Tunnel 1, we always send the HTTP connect in the case of the proxy communications. And that also basically increases the amount of connections that we may end up creating from the browser. So with the case of Tunnel 2.0, everything is put into one single data channel. We only support the lightweight filter in the case of Tunnel 2, unlike the options that we may have available with Tunnel 1.0, depending on what kind of traffic we're looking to intercept. So the way that we configure Tunnel 2 is the same as we've seen the other traffic forwarding mechanisms. We're just going to have to go in Tunnel, and from there we choose and between Tunnel 1 and Tunnel 2. Then we'll have some advanced configurations where actually you will see a little more options or some newer options here where you see that, for example, here, this is a little bit of an old slide because it shows the MTU manually created here. Now, after some of the newer versions, we have the option to have the path discovery MTU, allowing the client connector to set a specific MTU according to the connection requirements. We also choose options like the timeout and or if we want to prefer DTLS over TLS. These kind of things are very important and very helpful when we're talking about performance problems with Tunnel 2.0. For example, if we have a high latency network, we may want to switch to TLS since it might give us a better performance for that Tunnel 2.0. I had a situation or I had a customer that it was only CCC users and there were thousands of users all over the US. So that at the very beginning triggered a lot of complaints from their end users about specific performance because we're basically trying to use one single configuration for every single locations that they were in, which of course it might not be something that they will be able to handle. So we end up having kind of like a baseline of performance checks where we talked about MTRs, and we start gathering information. When eventually get to this point, usually it gets to high latency networks and changing it to TLS or adjusting the MTU values that nowadays it's actually an automatic response. Now here we have a graph of a representation for Tunnel 2 traffic. And once again, this is going to become very important since or when we start talking about bypasses here. So if we're talking about Tunnel 2.0 traffic, by default, the request comes out from the browser. There is no system proxy settings, and the lightweight filter is the one that's sending the traffic to perform the inclusions or exclusions. If the traffic needs to be excluded, then it will be sent back to the filter and then brought back to basically send it out, right? If the traffic is included, then it will be put into the data channel. So as you notice here, there is no hostname checks, there's no proxy actions, there's no app profile pack, right? Clear at this point, team, just to make sure?
David, what do you mean, no proxy action in this part?
Yeah. Over here, when we're talking about tunnel 2.0, there's no app profile pack, right? You see that this is red. The red, it's tunnel 1. The green is tunnel 2. So here, when we're talking about tunnel 2 traffic by default, we don't have an app profile pack file. So we actually have no pack files at all other than the system proxy. And that's not doing anything for us at this point, at least not by default, correct?
Okay, I got you. Thank you.
Yeah, so all traffic is tunneled on tunnel 2. That's why there's no pack, right?
Uh-huh. And it can include or exclude, but it only does that at layer 3. So IP-based ports and protocols, that's it, right?
All right.
All right. Now, for us to be able to create any kind of traffic manipulation at higher layers with a pack file, we basically gonna have to fall back the traffic and send it to the listener proxy port. Because even though the client connector is running tunnel 2.0, the tunnel 1.0, it's kind of like still running on the background. So you can still send traffic to the listener proxy port and eventually send the traffic over tunnel 1.0 out. For that, let me show you a document before we start talking about these options here and see it here on the slides. I'd like to show you a document that I think it narrows down basically all of this information within a very good explanation. It's scalar. This one right here. So this document, it's talking about how do we bypass traffic for tunnel 2.0. If we're talking about IP-based traffic, then we have these 3 options, right? So if we're having a VPN gateway bypass, we are creating this basically as only VPN interoperability. Why? Because this resolves the hostname to an IP address before adding the bypass. There are applications or host names that have multiple IP addresses, right? And if the client connector only resolves these once and then adds the bypass for the one specific IP address, we may eventually see the host name or the bypass not working. That's why this is only considered IP-based bypasses. Make sense?
Yep, makes sense.
Cool. Now then we have the destination exclusions and inclusions, which by default, we're gonna be including everything and excluding the RFC 1918. We can see that on the application profile, if I'm not wrong. And here are the exclusions and inclusions. And also we can do that for DNS request and for inclusions and exclusions. This is something that was added after versions 3.2. And eventually we then have also these IP-based application bypasses, which we'll talk about in a little bit more. Then let's go back here. We can do it also with the exclusions, but based on ports. So we can just add the port range or the port itself, and that also helps us out with the bypasses, right? Then we have these domain-based bypasses. I'd like you guys to first focus on these 3.8 or later. mainly because we're nowadays do not support lower versions than that. I think up to 4.0, it's the current supported ones. So here is telling us a couple of things that when we want to configure a domain-based bypass with versions 3.8 or later, we configure the app profile pack and select the following forwarding profile option, right? So what they're telling us here is that we need to configure this pack file, right? So the two options that we have available are this, that basically tell us that select to redirect web traffic to the Zscaler client connector listener proxy port. So what we're doing with this is that we are sending the traffic to here. We're basically enforcing a forwarding profile pack action. Just want to make sure that we're clear so far, team, that this is helping out and not confusing much more. Because this is important when we get to troubleshooting and once we start getting to understand how to use these pack files. Otherwise, we may have the configuration perfect and the pack file might still not be working, right?
So, for example, let's say we want to exclude the Microsoft domain. We're just configuring that within the pack and then everything else is basically the same. We're just setting tunnel 2.0. I guess you have to use this proxied web traffic. Yeah, if you can
This
show.
is this option right here. Yeah, let me show you. Let me put it to tunnel 2. And here it goes. This is the option.
Direct web traffic to Zscaler client connector listening proxy. So in that scenario, is that basically going direct to those domains?
It's basically doing the same thing as the tunnel with local proxy. Remember that it's sending traffic to the listener proxy port? So what we're doing here is that, hey, you're going to be using tunnel 2.0, but for all the web traffic, I want you to use tunnel with local proxy. That's what this is doing.
Oh, okay. I thought we were trying to single out. Okay, well, we are with the app profile, but then this is how we have to configure the forwarding profile.
This is on the forwarding profile for tunnel 2.0. And this is beyond the trusted network criteria, right? Because this is traffic, all traffic will be go to Zscaler. But what I'm doing with this is that now I'm basically having two flows. I have one data flow for all my non-web traffic, and will follow through here, right? And then I have another flow that will be tunnel 1.0 for all the web traffic, and will be
Okay.
following through here.
Okay. All right. I
Right.
got thrown off. You said a domain, and I was thinking that we were trying to single out the traffic flow for a particular domain, but that's not what we're doing here.
That's the thing. We still can. That's the next step here, because that first option does that. But you see that there's another one here, right?
Yeah.
So what we're
Okay.
doing here is that with that first option, we're saying do that, make two tunnels, right? But maybe I don't want to have two tunnels, because the point here is maybe not to send this traffic over tunnel 1. My main goal is to create some bypasses, right? So I can create the bypasses that I need in here, and I can still send the traffic back and put it on the data channel. So basically jumping from here to here.
Okay. Yeah, that makes sense.
And that's what that second option is doing. We can see actually here a table of what happens with one enabled and the other disabled, both enabled, or so on and so forth, for the web and non-web traffic. Feel free also to play around with that on your lab. You can totally reproduce that by just playing with the options and then generating some traffic and then afterwards checking the logs.
So if I understand
Right.
this correctly, when you have 2.0 enabled, if it still has the ability to use 1.0, it sounds like it will.
Yep, it definitely will. And
And then
it
it's
will use it.
additional stuff, right?
Uh-huh. Yeah, you can basically you can only use tunnel 2, you can use tunnel 2 and tunnel 1, or you can use tunnel 2, use tunnel 1 to create the bypasses, and then come back and send everything to tunnel 2. So you can do basically anything you want with those two tunnels.
Oh, okay. So it's both additional features or new unique features, depending on how you've configured it.
Mm-hmm. Exactly. If I'm redirecting only web traffic, I have two tunnels. And then I have the bypasses, right? Which are going through here. If
Is
I
that the only
have
way?
both,
Sorry.
no, go ahead. The only way
Uh, is
for
that the only way
bypassing?
to make stuff go direct is through that proxy option?
Yeah, it's the only way because otherwise the pack file is not even read by the client connector, right? If we're not redirecting here, then the traffic is only following through here and it's never seeing the pack file. Now, once it's here, we can decide if we come back or if we just keep going through tunnel 1.
Okay. Is there a, is tunnel 1 going to be deprecated at some point?
Not really. No,
Okay,
I
so it's
don't
just
think
like,
so. At least go ahead. Sorry.
well, no, I was thinking it, you think about it like, okay, well, 2.0s, and then you have that Zscaler 3 cloud now. So I guess I just think about it as a, that being an old one, but I may need to think about it as, just a different, just this basically just a different service or different functionality.
Correct,
That's what I'm
correct.
picking up on
And
too.
most of them, yeah, and most of them are dependent on each other because tunnel 2 it's still basically dependent on tunnel 1 for all of this traffic manipulation. Tunnel 2 on its own, it's basically just one pipe sending everything into one destination, right? And we still need to have some flexibility. So yeah, it's definitely a part of a whole ecosystem and not just something all that will be eventually gone. It's part of a whole thing, yeah.
Is Tunnel
All right.
2 part of the TCP stack directly?
Yeah, well, it creates an SSL VPN tunnel basically. So yeah, at the end it
Oh, so
uses
it is
the
actually its own adapter then.
actually it uses the lightweight filter. So it uses the adapter, I think, from the client itself. I'm not really sure. Let's double check because at this point it does have the adapter because I used these other options, but I don't think it's using it right now. Let me just update the policy here so we can go back to tunnel 2. But I don't think it's using the adapter at all. It's using the lightweight filter. That definitely it's using it because if we take a packet capture, we get two PCAPs. We get the packet capture from the actual adapter, which is basically the network card from the client. But as you see, this one is not being used, right? This one, it's
Oh,
being used when we use route-based, right? But
okay.
in this case, it's only using this one and the lightweight filter.
Yeah, so it's closer to a true tunnel,
Yep,
but it's invisible. That's kind of cool.
exactly. Yep. Nice. All right. So let's keep on going here. And this will be mainly just a recap because we basically just saw all of those options there. And just a little bit of how the inclusions and exclusion works. The more exact you are, the that's the one that will be taking precedence. That's basically how it goes, right? So a more exact match will always win, and if both are the same, the inclusion will be taking priority. Now, here is the manual way of how things were done before having those two options there. I prefer to show you those two before getting here because you can actually get the exact same behavior than you had with those two checks, but just by creating a couple of pack files, right? So if we go back to the document that I was sharing before, let me see, where did I put that one? The option with 3.7 or earlier was to configure two pack files. One on the forwarding profile, that's sending traffic to a variable, right? What is this variable resolving to? What do you guys think? Let me see, any idea? Ruta, you there? Let me see, you there, Amrita? Okay. All right, I'll get back there with you. Let me see. Aditi, how are you? Hey, Aditi, you there? Guys, just double checking. Is it me?
Yeah, we can hear you.
Can you hear? All right. Okay, let me keep going there. Let me see. Hey, Jason, how are you?
Okay, yeah.
Hey, hey. So what do you think this is resolving to when the pack file is downloaded? Any idea?
Maybe
Let
they
me put
send
this
the
image back.
okay.
Uh-huh.
They send the traffic to just
A couple of highlights here. We have it on the 14 profile pack.
okay, okay for it.
It's this statement, right?
Mm-hmm.
And what do you think this is doing? Where is
What
the
is
14 profile pack used?
bypass just direct to the
Yeah, but where is it enforced? Is it enforced on the client's machine? Is it enforced on the client connector? Where is the 14 profile pack enforced?
the client connector.
All right. Well, it's actually on the system proxy, right?
Oh, okay.
So yeah, forwarding profile pack, it's on the system proxy, and it's telling us this tunnel to bypass, right? So what do you think this is gonna be resolving to? Any idea?
If you need send some different traffic to different destination, then yeah, just bypass some.
It's gonna be resolving to the loopback IP, right? Because remember, what we're doing with this is we're trying to send the traffic to the client connector, right? So with enforcement of this action, what we're first doing is say, hey, send this web traffic for domain that we want to bypass to the listener proxy port, right? So then once we enforce that action and the traffic is on the client connector, we can enforce that direct action. Okay, once again,
Okay,
this is
okay.
just just to show how it was done before, right? You don't have to configure these pack files anymore. At least not if the customer is not using something as old as 3.7 or earlier. Nowadays, you have the other two options that are much more user friendly. But this is good for understanding how these pack files work and how the traffic flow is going through the client connector. Make sense?
Okay, okay, got it.
All right. Excellent, team. Thank you so much. And let's see how much we have. Once again, here is another example of that same configuration. And just remember, this will be translating to the 127.0.0.1 within the port 9000.
One question, like if I want to bypass any URL, should I add it into the yeah, forwarding pack file also, or it is only in the pack profile?
In the
When
case of 3.7 or earlier, you have to add it in both, right? But now with this new option available, you don't need to have anything on the forwarding profile pack. All that you, or the only thing you configure is the app profile pack. You don't have to worry about configuring the forwarding profile pack anymore.
Okay, because previously there was some confusion, like we use it to add in both pack forward as well as app pack profile. Yeah.
Yeah, I remember, and that's one that I think was one of the main reasons why they come up with this option here, because it's easier to just, hey, go ahead and send everything, and I'll give you to send it back after you bypass everything, other than having to manage those two pack files. I remember when Tunnel 2 came out initially, that was super painful, and
Yeah,
I
that
don't
was.
consider myself very good at pack files at all at that matter, and having to create massive configs, yeah, was definitely a challenge.
Okay, thank you.
Cool. All right. So here's basically what we can see for the Mac OS devices. In those scenarios, we don't have a lightweight filter. So we need to basically intercept everything as a VPN adapter, basically, and just sending everything to this synthetic IP address. So we talked about the trusted network a little bit already, right? So this is an option that allows us to change the way the traffic forwarding mechanisms are working, or the way that the client connector is forwarding traffic. And depending on our current location and or different parameters, like our default gateway, a specific host name to IP map resolution, or even if you have a specific DNS server or your adapter is part of a specific subnet. We can combine also different criterias to try to make our trusted network criteria as complete as we can. Now, some of the most common issues that we can see with the client connector is performance issues. Remember that with Tunnel 1.0 and route-based, we're converting some of these packets to streams. We need to install the adapters. So we may see different behaviors in regards to performance. Overuse of things like the DNS resolve function can cause delays on the parsing of the pack file from the browsers. So those kind of configurations or overuse of those configurations may eventually cause also a performance problem. When talking about Tunnel 2, again, there's a whole conversation around that, but usually overall performance will start by narrowing down the network path between the client and the service edge. From the Zscaler support team, a performance check should be reviewed or should be in place. You can also check things like the trust portal to verify for any events that may have been affecting the cloud at the moment too. Have you guys seen this the trust portal before? Trust.cscaler.com.
No.
No, I don't
Okay,
think
let
so.
me. It's a public website. You can register. You can have RSS feeds provided to many options there. But it basically provides you status of the cloud, right? If there's any maintenance schedule, you can see those in here. If there's any incidents, you can see them also in here. And you can see that for basically all our clouds, the ones on CIA, the ones on CPA, CDX, and much more. So yeah, want to see Zscaler 2, we see that there's a service disruption issue reported on September 14, and it was remediated that same day, but here we can see some further events about that. Also, depending on the incident and things like that, or we can see the RCA attached to it, or you could have also the option to request that RCA to the support team. So again, a lots of different useful information that will let you know much more about this kind of information. The regional searchers ones, this is actually very, very useful. All right. Let me share this link with everyone. There we go. All right, now we can have also issues with integrated authentication. Sometimes the clients may have certificate-based type of authentication, or could have MFA or multi-factor authentications with UV keys and stuff like that. So we may need to rely that type of authentication with the browser instead of the client connector. There's an option where we can still use the browser for authentication, although it's basically the client connector enforcing the authentication. VPN and trusted network criteria failing could be happening because of the adapter is not being detected. There's a couple of best practices under the forwarding profiles configurations and help articles as well. We may see also scenarios where the client connector is seeing a error because of an internal or an antivirus or firewall service running on the endpoints. If we are not allowing the Zscaler services, or if we're blocking some of the health checks that the client connector is doing, then we may see those kind of errors getting triggered. Captive portal, as we know, that's a option, as you may know. It's a service that allows or needs you to authenticate or provide some sort of acknowledgement before you're allowed to go out to the internet. If the client connector has some sort of service like that in between, it won't be able to connect with the service edge. So the client connector generates a GET request expecting to receive a custom response. If that response is not received, then it will fall into this captive portal detected state, which is basically disabling for a specific amount of time, giving time the user to either acknowledge or authenticate on the required portals, and then being able to connect to the internet. Finally, one of the main things that you can see with the client connectors as well are domains not working, domain bypasses not working. Remember that best practices will will become very important here, because if we are creating a bypass where we don't have to be configuring it, or where it might be taking it, but it might not be the best place, like for example, the VPN bypasses that we were talking about, then we may start getting some unexpected behaviors, and that's where all of these kind of cases start flowing. So once again, following best practices and documentation should be our first step within any kind of deployment in general.
Is I had an issue with captive portal, and ours was set to I think 30 minutes to disable itself for 30 minutes. So they should be able to do the authentication within that 30 minutes, and then once they're on the network, will the client connector immediately start trying to form the tunnel again? Is once it realizes there's a connection?
It's actually after the 30-minute time frame is complete. It doesn't have a way to
Oh,
know if you authenticated or not during that time frame.
so
So usually by default, that's actually just 10 minutes. So yeah,
yeah,
that
that's
might
too
be
long.
too long of a time frame. Yeah.
Yeah, so that was probably the issue then, was that, I mean, and the issue was that they couldn't access the company resources, but yeah, they just, you know, hadn't hit that 30-minute. That's way too long. Wonder
Yeah,
what the,
definitely too long. Not sure
all
why
right.
they would put such a long time,
I
but yeah. You should, by default, it's 10. Yeah.
I thought it would just start trying again, once it got network, but and that's I thought I had read that, but I'm glad you said that because that makes a lot more sense.
If it detects a change on the network, it might try it. It might try to restart the service, right? But if nothing changed on the network at that point, then it basically just stays there. Yeah.
I would even set it for like 5 minutes because it doesn't take 5 minutes to go through a captive
I think
portal
the minimum is
authentication.
10. I think the minimum is 10, if I'm not wrong. I think I tried doing less than 10, but I don't recall at this point. Maybe I'll need to try it again. But yeah, yeah, definitely play around with that timer. Should do the trick for that case.
Gotcha.
Cool. All right. So here we have a scenario where we are getting a customer with the client connector enabled with Tunnel 2.0, and they're having or they're sharing the logs or the MTRs in this case with us, right? So remember that the MTR, it's a option, or it's basically a tool that will be run either on the endpoint to the SME to measure all the hops that that node is taking to get to its destination. And also from the Zscaler support perspective, we can run an MTR to the client's public IP address, measuring as well all the hops that could be in the network, right? So let me see 1 second here. Seems like my machine is a little stuck here. Bear with me just a moment. Actually, let's do one thing here, guys, because it seems like either my machine is about to crash or something's about to happen. I should have installed some updates, it seems. So let me check on the current time. It's 1 hour and 20 minutes. So how about we have our first break? When we're back, we'll go and do some of these. We have like 3, 4 exercises. So we might be end up doing 4 groups, and we'll be, oh no, we don't have the option for the breakout rooms again, sorry. So well, we'll see how we can manage those 4 exercises to try to make it a little bit more fun. And once we go through those 4 exercises about troubleshooting with the client connector, we'll start with some user authentication. All right.
All right, sounds good.
Thank you so much, Tim. Have a good one. I'll see you soon. All right, everyone. Hello and welcome back. Let's stop the timer here. There we go. So please, just to check on the attendance, raise your hand or let me know in the chat so we can continue with the session here. All right. So now we'll be talking or we'll be going through some lab exercises and just to go through some of the actions that we need to take whenever a specific issue might be encountered. So we have 4 labs. So we'll be, I'll try to kind of like make it in different ways. So we can, I'll be maybe asking some of you guys to share your screen. I just shared all the attachments for the 4 labs on the Zoom chat. So let me know if you can download that or if you're having any issues with that. But you should be able to see it there on Zoom chat. All right. So with the first one, it's about an MTR or basically a performance situation. Let me share back my screen here. There we go. So in this case, we have a problem where the customers are having tunnel 2.0 and they're complaining that they have slowness. Whenever the client connector is off, they don't have any problems and they overall have a poor performance experience and they're using a speed test to measure the performance. Now, checking with a speed test tool might not always be the best option to check, even more against a proxy service, right? Because it may not provide us with the overall view of an actual performance. It usually only measures the time to first byte. So to actually get a average performance view, it might not gives us all the information that we need, right? That's why we end up having or running a MTR. So anyone's not familiar with the MTR? All right. So let's do a quick test with our lab environments now that we have a user with or we have connection to Zscaler. We may end up doing a couple of tests just to measure performance for these clients. So for now, let's just check on one thing. We see here that, let me just get here, see we should have now the connection there. Oh, it's still trying to use the Zscaler tree. Let me see. Maybe I had to, oh yeah, I haven't changed this pack file here. So maybe I'll just go ahead and configure this profile a little different. Let me go here. All right. So let me get into the client, update the policy, and we should be okay. There we go. All right, now what is a very important thing to notice here, at least from the very first initial view of the client connector, before we even start running a performance test? Also, I'd like to double check everyone has a CI account right now and everyone has a user connected with their Windows machine, right? So everyone is following me here. If anyone need
Not
time
just
to
yet.
fire up the machine.
Yeah, my VMs were suspended, so they're still starting.
Okay, cool, no worries.
But actually, they just
Let me know
finished.
once. Okay, cool, excellent. All right. If anyone needs a couple of minutes while their machines are starting, let me know. So we can basically all go with the practice here, okay?
Hey, sorry to interrupt, Davis. The same password as yesterday, right? But I'm not able to log in to the Sky tab.
Well, the SCAD tab should be the one that Hitesh provided on the email, right? But yeah,
Yeah,
it
I'm
should be the
using the
exact
same
same.
credential.
That portal should be available for about 2 weeks. Let me maybe see if there's anything there, but yeah, it should be the same. Just double check that there's no spaces or anything even at the beginning or the end of the password. That might be it, but yeah, it should be the same.
Yeah, I'm actually trying mine again, and I've tried two different browsers, and it doesn't work.
Hmm, let me double check, guys. So
I'm
one
using the
is
link he
here.
sent me.
No, it's starting to work now. I have no idea
All
what
right.
happened.
All right, cool. No worries. Clint, let me check on yours.
It says, "Can I access the reference virtual machine?"
Maybe, but is it the link for the VM or the link for the portal? Try the link for the portal. That might be the one. Let me
Oh, you know
paste it on
what?
the.
I think I see why. Um, Never mind. I clicked on the link I had for the previous lab. My bad. I'm good.
Okay. Okay, cool. Excellent. All right. Okay, I'll just give a couple of minutes while those machines are starting up. And in the meantime, just let's take a quick look at some of the information that we can gather or that we need to check from these client connectors, right? So right now it's telling us that we are connected over tunnel 1.0, and this is the server that we're connecting, right? Now that is the virtual IP that our users are sending the traffic to. Now, this is not on the browser because if we're using tunnel with local proxy, the browser, it's sending the traffic to 127.0.0.1, and then that traffic will be sent to the virtual IP, correct? Now, if we want to measure performance, we also need to check the SME that the customer or the client is connected to. Usually, for a more exact measurement, we might end up looking at things like like some internal tools to find specific sessions. But just overall, we can look into or using two main tools. One is ip.zscaler.com, and the other one is speedtest.zscaler.com. That one will also help you out with a few other performance checks that we can use. But overall, we can see the information of, for example, the SME that we are connecting, as well as the service IP of that SME. This is the IP address that the internet will see as our outgoing IP address. If I go to something like, let me first of all turn off this CPA, because I have some source IP tools in there. Let me see, for example, what is my IP? Just like that from, let's see this one. Oh, this one is definitely not in this one. It's in my IP address. It's not showing Zscaler's IP address. That's interesting. Let's see this one. This one is showing me Zscaler's IP address, right? You see that it's the same. Actually, it's showing 48. Yeah, 48.166. Oh, wow. Just a few ads. There it goes. All right, so here we see, right? The IP address that the internet is seeing for our connection, right? So as the MTR, we can run the MTR to the virtual IP. That's the one that the client connector is making the tunnel against, or we can also send it against the SME IP, which is the one that is connecting to the applications. Make sense? Yes, no, maybe?
Is the 136 address the VIP?
No, that's the SME IP. The VIP is
Okay.
this one right here.
Oh yeah,
On
that's right,
the,
on the connector. Gotcha.
yeah, over here. Yeah. If we resolve, for example, let me go here to the config page. Nope. That's for Zscaler 2. Just to check here, I'm connected to the data center in Washington, right? So let's look it up here. Okay, here's the SME. I think it's this one. Let me see if it's Washington 1. Yep. So if I'm not wrong, if I resolve this, because there might be multiple bips, so it might give me a round robin behavior. But ideally, if I do the NS lookup for that host name, oh, I see it's giving me a different one in this resolution. So it might
That's the
eventually
VIP.
connect to a different one. But those two are bips, right? Because you
Yeah,
see that
okay.
this one is 195.19 and this one is 194.41. There's more than one BIP for that host name, just so we can do the whole load balancing stuff, remember? But in this case, it's getting this one, right? Should be this one, but I guess I'll check. All right. We can also just use the host name, right? But that basically is what the connections that we can do or attempt. Now, should I just go ahead and create the MTR for these connections? Or should I maybe turn off the client connector before I do that?
I mean, you're gonna need both, right? Because you want to see before and after. if we're trying to troubleshoot performance?
That's the thing, right? When we're with these MTRs, the only thing that we're checking first, it's how's the path between the client and Zscaler, right? But we're actually not measuring performance yet. We're just checking is if between these two endpoints, there is anyone here that might be adding things like latency or any kind of packet loss, right? That's basically what we're checking with these MTRs. Beyond that, we don't know if they're handling a specific throughput or if it's taking a specific milliseconds to handle a TCP transaction or UDP, because this is only running ICMP messages from point A to point B.
All right, so you're basically measuring layer 1 and layer 2 stuff only.
Exactly. So that's kind of like a first initial check, right? To check on higher layers, we have a few other options, and actually we'll take a look at a few that are in this speed test tool. But yeah, for now, that's kind of like the first thing that those MTRs are doing. So we actually need to have the client connector off to run those tests. Because otherwise, if I try to run right now a connection to, let's say, 104, 129, 195.19, well, it does give me that one. That's right. That's right. I didn't take into account one important aspect here. And sometimes I'll see it, sometimes I won't. In this case, it won't be that relevant. That's right. I totally forget about that. I always I was thinking always that I had tunnel 2.0 here. And it's tunnel 1.0. So in this case, it's all right. Or we will be measuring that outside of the tunnel. If I will be using tunnel 2.0, then I won't be seeing all of these hops. I will only be seeing the BIP and going basically like one hop away because I'm going inside of the tunnel. Make sense?
Yep.
So yeah, in this case, it's not relevant because the ICMP traffic is not intercepted by the client connector. So we can actually do some kind of test like the one we're seeing here. Now, before we go into the exercise that we have here, and since we're doing this practice here, let's just let it go to 100, and we can see if there's any issues that you guys can observe, or what do we see out of this MTR.
So if I trace route to Google, would it show the end or is gonna show just to Zscaler?
I'm actually not. In this case, it will actually show the path outside of Zscaler. If we're using tunnel 2, then I think it will show up to the SME. But I guess I'll need to. We can test that one out once we change it in just a moment here. But I'm not 100% sure. I haven't tested lately. Okay. So, any volunteer? Should I pick someone up to help me out to read this MTR? Let me see. Hey, Barsha, how are you? Might be double muted. Hey, hey. Let me know if you can unmute so you can help me out with the MTR a little bit here. All right. I'm assuming there might be some. You there?
I can share screen,
Got unmuted.
but I cannot get to speed test Zscaler.
No worries. We don't, at this point, well, did you run the MTR also from your end?
Yeah, but I did it to like Google instead. I can clear it and start again.
Yeah, do it against the BIP, because yeah, for now we'll be testing that connection, right, between the client and the SME. And in this case, if you were running tunnel 1 or tunnel 2?
It looks like tunnel 1.
Okay, so yeah, in that case, even that connection won't be even going through Zscaler. So yeah, it might help as a reference for maybe testing later with tunnel 2. But yeah, for now, let's run it against the BIP, that one, the one we see on the client connector.
Okay.
Cool. All right. Yeah, Barsha, I couldn't hear you. Not sure if it was just me. All right. Yeah. Might follow up on with you on that. No worries, no worries. So let's see who else can help me there. Colby, how are you?
Hello.
Hey. So, um, let's see. Can you help me out with this MTR? Let's read it together and let's see what we can find out. Sounds good?
Yeah.
All right. Thank you. So let's see. We have about 7 hops, right? And we see a few of them that are showing us some packet loss. Is that something that I should be alarmed, or what can we say about that packet loss that we see here?
You're
Any
asking like if
idea?
we should be alarmed about the packet loss? I mean, one of them is 100% packet
Yeah,
loss.
yeah, one of them shows kind of like 100%, but yeah, should that be alarming? Should that be, is it expected maybe? Any idea?
Considering we're still getting packets returning from the next hop after that packet loss,
Right,
I
but
don't think we should be
100,
alarmed by it.
but yeah, but 100% packet loss doesn't sound like it's actually that, right? Because if we take a look at this, they saying that they lost 100% of the packets, but this hop is still receiving 78, right?
Right.
So that doesn't quite match, right? That's usually because these hops are not responding basically to the ICMP packets. So it's expected that we see these kind of things when we're running basically any trace route on the internet, right?
Right.
All right. So yeah, that packet loss, it's all good. And it seems like overall, we may have some of these that are telling us a similar story, right? Like this guy, it's telling us that the first hop is losing 32% of the packets, but the hop that is right next to it, it's still having the 102 that the first one it's sending, right? So again, it's not like the actual packet loss it's happening. I'm still seeing the 102 packets traversing that endpoint, correct?
Correct.
So yeah, that's the kind of things that we can narrow it down when reading those MTRs, because again, they're not the definite answer for everything, of course. They're a good baseline to understand how the network might be and if there's any potential issues. Because let's say that I have here that they're losing just those 44 packets, and then those 44 packets are also seen in the rest of the trace, right? So in that case, we did lost the packets because they never reached to their destination. So in those kind of cases, we do follow up and basically see if there's, or why is that a specific hop blocking or dropping the packets that we have, right? It may be issues with the ISPs. It could be lots of different things.
So this is per hop sent and received?
Yep. This
Okay.
is every hop from these 10.0.0.254, which is the gateway for this guy, to the virtual IP, which is the front door of Zscaler. Now, the virtual IP itself does treat ICMP as low priority packets. That's why we don't see the full number there, right? But again, is most of the time expected to see within those timeframes. It might be that we have some packet loss here. We might not have the whole story here. But again, we can do further tests to actually measure further down that way. But overall, it looks like nothing out of the ordinary that at least corresponds to packet loss and the send and receive packets. Now, the other thing that we can see from these MTRs are the average best and worst latency, which in this case, it seems super low, right? And following the same logic as the packet loss, if the latency is not maintained across the nodes, then we're most likely not seeing an actual performance problem. For example, here we're talking about one packet was recording 44 milliseconds out of 98 that they were sending, right? So with an average of 8 milliseconds, it's definitely more than okay. Any questions so far? All right, I hope this works as an initial overview. We use the MTRs a lot, and these kind of tools from the client connector and from the speed test tool, and with the help of the client connector, will be giving us that kind of measurement or that kind of information as well, right? So let me see what's going on. It seems like I might need to be running. No, there you go. It's telling me that I'm connected over tunnel 1.0. It gives me a map view of the location of the user against the data center that they're connected. Gives me upload and download, the average jitter, and we can see also an overview of the hop by hop that we just saw on the trace here, right? And we can see a command line view of that connection there. This is from the Zscaler service edge to the client egress IP address. So with these two in place, we can see the upload and download path for this specific tunnel from the client to the service edge and from the service edge to the client's IP address. That's why, again, we can also run that against the specific SME IP instead of the BIP, or sometimes we might want to do it against both. Make sense? Is this
Yep.
helpful, guys, to see how to troubleshoot maybe a performance issue with the client connector?
Yeah, but
Yeah.
in the instances where we have a customer that's using ZPA, where they're connecting through the exchange, would we get to see that here as well?
Well, no, CPA will be a little different. This is all CIA troubleshooting only. We do have a CPA course as well, where we go in depth into that. But yeah, CPA has its own counters, and actually, is in many ways I like it a lot more because the portal itself provides you with a lot of information that's easily helping troubleshoot something. Okay, so let's see. Another thing that we can do, and notice how this is only available after versions 4.4 of Windows and 4.3 of macOS. But this will also help you with a ton of information that will provide more details about the performance from the client to the service edge. Let me show here. In this case, not much because it's still tunnel 1. in the case of Tunnel 2, it does provide an overall view of the path of the tunnel status information. So it's a very, very detailed overview of that. I guess we'll be trying that out when I get to Tunnel 2. I forgot I'm still in Tunnel 1. All right. Now let's go over the exercises now that we have a more oriented view of the pathing of the MTRs. So in this case, we have a client side and Zscalers to client MTR, and we'll be checking basically what do we have from those scenarios, right? So anyone would like to share their screen with the MTRs? The ones that I shared on the chat prior to
I can share
coming back.
screen.
All right, sure, go for it.
Hold on, let me. I hope it's not too delayed because I'm on hotspot. I was in an outage. I'm still in an outage. Let me know if you can
Oh,
see my
okay. Yeah, I wouldn't
screen.
want to also I wouldn't want to take your bandwidth, so that's okay, right? That you can,
Can you see
if
my
I'm not
screen?
taking. All right, yeah, we can see it.
Okay, is it this one? The one that you were looking for?
That one, that is one of them, if I'm not wrong,
Uh-huh.
and there's another one,
Oops.
right?
Yeah, let me find
Uh,
it because I just closed it. Is it this one?
yeah, that's the other one.
Okay.
Okay, we can put them side by side.
Yeah. There it is.
Okay, well, this
Oops,
one,
maybe you can see the
we
whole
might,
thing.
yeah, we might be making this one a little bigger, or make it maybe just on the top part of it, so we can see all the parts, because yeah, it's kind of like a lot of details there. But no worries, let's take a look at one, and then we take a look at the other one. So no
Okay.
worries. This this first one, it's from the client to Zscaler, right? So this one right here, it's from
Mm-hmm.
the client to the Zscaler service, right?
Mm-hmm.
So do we see any issues that could have been causing a problem from what we talked before?
Well, it's 4%, right? We're missing quite a few, like four,
All right,
five,
4
five
ICMP
packets.
packets out of 150, 100 something.
Uh-huh.
Might not be too alarming, right? At least not for now, because
Right. This is.
that could easily branch into the low priority packets,
Mm-hmm.
right? Also, it's still maintaining the 151 afterwards, so it seems like
Mm-hmm.
it might just be not seeing
Yeah.
them, right?
Yeah. Same. I mean, just here too, and then here.
Hmm,
I don't know about that. No response from host.
okay. So the most important thing is that you see the same here and here, and that's
Mm-hmm.
roughly what we're seeing, right? That those 151 are actually making it to the
Oh,
end.
I see. Yeah. Mm-hmm.
All
So no
right.
issue there.
No issue there. Yeah, no issue there. Also, the latency overall, if this 100 and something would have been maintained up until the last hop, it will be worth investigating a little more. Even then, it might be worth checking a little more what might be those hops there,
Mm-hmm.
because it seems like it's prior to going out to the internet. You see, all of these are just internal hops.
Mm-hmm.
So it seems like it might be just not that bad in regards to the average latency, right? It's
Yeah.
about 40 something. Now,
Yeah.
let's go to the other end, which is the Zscaler side, right? So let's make this one full screen so we can see all the values there. There you go. Yeah, that's good. All right. So same drill. In this case, we're from the service edge to the client's public IP. That's why we don't see all of those internal hops, right?
Right.
So
What about
again, right?
this?
Do we see?
No,
All right, same. All
it
right, yeah.
kept the same thing, no?
Exactly. That's what we're looking for, right? Even though it might be giving me an alarming or high number here,
Mm-hmm.
if the packet it's maintained across the path, it's basically not actually a packet loss, right?
Right.
And same thing with the latency. Average overall looks good, so that's totally fine. And even the worst, it's not maintaining again any latency, right? It's not like it's 50 here and then 60 and then 70 or 50 and 50 all over the place, right? So yeah, it
Mm-hmm.
looks like at least in this case, the network might not be the problem, right? Now,
Right.
we get to these situations, unfortunately, often if we don't set the expectations with the customers, right? Where they complaining about a performance issue and they're coming back and you ask them for something like this, and when you come back and tell them, hey, this came out clean, it's like, then why did you ask me for this? Right? Why this is not fixing my problem? You know what I mean? They see it sometimes like a waste of time, and that's why we got to make sure that we set the expectations. Sometimes this might be the first step, but out of a whole plan or part of 2 or 3 things that I'm asking to the customer. It's not usually just the MTR. It's always part of the conversation and the isolation process that might take us to the MTR or not. Make sense?
Yeah. Yeah, like
Right, all right.
setting the expectation, right, of where we're looking at.
Exactly. Yeah. In this case, they're telling us about a web performance issue, right? So we
Mm-hmm.
need to basically come up with a plan. Where is the performance might be triggering? We need to check if Zscaler is not having any problems on their data centers at any level with maybe Trust Portal, Trust Post, and stuff like that. Even just checking with them, hey, can you review the performance for these connections, right? And from our part, starting with these kind of tests will help us out to view even both ends. You saw that even from the client connector perspective, that speed test output basically gives us the traffic that should be coming back. So it's quite helpful just to get to see at least this very first initial part that tells if we need to further down conversations with the ISPs or continue checking at higher layers with maybe packet captures or header traces, right?
Mm-hmm.
All right, all
Yep.
right. Cool, cool. Thank you. Thank you so much for sharing your screen with that one. Are there any questions from anyone else from the team on this exercise? All right, all right. So let's continue. On this second exercise, we are talking about a client connector that's performing VPN bypasses for Zoom.com. So the customer is telling us that they cannot load the website. They basically should be bypassing that traffic, and something is happening that might not be hitting that bypass or so on and so forth. Now, based on what we're seeing here and just taking a look at a couple of keywords like VPN and Zoom.com, should this be the bypass for this application or should they do it in maybe any other way? What do you guys think? Let me ask someone here. Hey, Gino, what do you think?
Hi.
Hey, hey.
Um,
So
actually,
should
we
they be? Sorry, go ahead.
I'm sorry. I'm still thinking because
Um, First of all,
So
need to
let's do
check.
one thing. Let's do one thing. Yeah, let's go over the documentation, right? That might be one of the first things that we might be look for, right? Let's say that we might not be sure, right? So the first thing that I will be doing is maybe what is the VPN hostname bypass? What does it do that may or may not be affecting these kind of situations, right? Now, if you recall from the document that we shared about that I shared about Tunnel 2.0 best practices, this is just an example. We may find this information in other places, but here they're talking about those VPN gateway bypasses, right?
Yes.
So they're telling us that it creates routes and filters for direct traffic, right? So we can use IPs, FQDNs, or subnets. It's the highest priority of all the bypasses. And it can also affect IP-based applications. And it's the system set to ignore VPN traffic without the client connector needing to process the bypass. Now, one key thing, it's talking about VPN traffic, right? And it's telling us that it will create routes. Along with that, we have here a little warning or a little note that is telling us that if we use a host name, it resolves the host name to an IP address, and then it adds the bypass. So for every host name entered, a DNS resolution is performed by the client. One thing that they're don't telling you here is that this DNS resolution is only done once, right? So what will happen here is that they will be bypassing zoom.com, but for the only for the very first IP that it resolves, right? So an application like zoom.com may have multiple IP addresses, right?
Right.
So let's take a look. Now that we have a little bit more of a baseline of what might be the issue, let's take a look at the client connector logs, all right? Would you like to help me out sharing your screen and taking a look at the logs?
Sure.
All right. Also, Tim, once again, you can also open up those logs by
Is it the
going
one you want?
through the ones, yeah, from the second exercise, lab exercise 2, yeah. All right. So we can use different options. What I do is that I unzip the folder and then I use Notepad++ so I can look for specific keywords in all the files. Because with the zip folder, it doesn't allow me to do that. But we can, in that way, just look for specific keywords like zoom.com, and we don't have to look into every single file because there's a bunch, as we see, right? Going through every single one of them will be a nightmare, right?
So which one you want me to extract?
Look, once you that lab exercise 2, that's the one that we will be uncompressing. And now that we are on, or once you have it uncompressed, we'll go in Notepad++ and we'll use the option to find in files. Right.
Okay.
All right. Now you can
you
can
see
go
my
into Notepad. Yeah, I can see your screen. I can see the file browsing, right? The file is uncompressed already, right?
Yes, but already extracted to the folder.
Okay,
on
perfect.
computer.
Perfect. Okay. So let's do one thing. Let's go to Notepad++.
Also, what's the mean? What do you
The
mean? Sorry.
Notepad, the Notepad++ application. Do you have it installed in your machine? I think I see it here, right? The Notepad++. the one for the text editors. With that tool, we can search in that
Oh,
folder.
okay.
That's what I
Okay,
wanted
okay.
to share. Yeah.
Yeah, I got a Notepad++, yeah. And then
Yeah. So go and do under search option here. Oh. Under search here. Yep. There's an option here. Not on yeah, on the search up there. There's an option to find in files. So yeah, use that option. And here we're gonna be first putting the directory where our logs are. So use the three dots. And you're on CIA Bootcamp. That's where it was, right? So you
Yes.
select the folder. And now you can look, for example, here for zoom.com. That will search every file that it's in that folder and look for the word zoom.com. So let's go for it. Let's just type in there, for example, zoom.com on that search.
comes.
Yeah, that was the bypass, right? So we can use that.
Right.
Mhm. And we can do find all.
How do you tell it to look at more than one file at one time?
We basically select the directory. Can you go back there 1 sec, Gino? Go back to the search option. And when you use finding files, you need to click on the three dots. So you
Oh,
tell it the
directory. I see it.
directory. Yeah.
Okay.
So once you
All
choose
right.
that, then it basically looks everything there.
Thank you.
Cool.
What if we don't
I
have Windows?
sincerely did not know that.
There you go. So if you don't have Windows, there is a macOS application called Sublime Text that I've heard that it's providing you with very similar options or experience. That's one option. Also, you can do it from the command line and grab it with those options. Just look into the whole folder. And I think there was another one, but I don't recall. I don't think it was Visual Studio. It was another one. But at least those two options might be available for non-Windows users. All right. Now, let's see. We have there a few logs about zoom.com, right? It's showing us the list of the bypasses that were applied for the VPN bypass. And here we see where zoom.com was part of it, right?
Mm-hmm.
Then it started debugging that host name, doing the query. And we can see that the excluded hostname for zoom.com is resolving to this IP address, correct? Then any subsequent request, it's telling it, hey, go ahead and look it in the cache, right? So far, so good?
Okay.
All right, now this is under the CSA tunnel file. This is important because this file, it's actually one of the most important ones that we're gonna be looking for. The thing is finding which one when you're having a lot of them, right? That's why these tools are super handy. But usually you will be looking into things like this file for mainly all the transactions that are happening through the client connector. For other things like authentication errors or driver errors, we might be looking into some of the other files. But overall, for connectivity, bypasses, and stuff like that, we're going to be looking at this file. All right.
Mm-hmm.
Now, let's look at that folder and see what else we get, because we can see that the traffic was added to the bypass list, right? But they're telling us that after they added that, they basically started seeing something happening or something is not fully working. So let's see if we may have something else, right? I think in this scenario we do have a packet capture. So let's take a look at that. Let's take a look at the folder again. Do you see a pickup there? Nothing there? All right, there was a few. Okay. So let's
There are
see.
two
There
of
was
one,
like
two, four.
adapter and LWF, right?
Yes.
So LWF, it's what the lightweight filter it's doing, which in this case, it's basically what most likely will be using those bypasses. It also seems to be the one with the highest size. So almost likely gonna be grabbing this one. So let's take a look at this pickup file. It seems like it didn't extract the pic. Oh, there it is.
Okay,
Oh,
there.
do you have Wireshark installed?
Not on my laptop.
All right, so that okay, no worries. Then let me see if because I don't want you to go through the installation right now just for the
I can
testing.
share screen again if you
Yeah,
want.
All
I
right,
stopped
all right,
sharing.
go for it.
Thank
Good,
you.
thank you. I don't want to starve your hotspot.
Oh, no worries.
So
Hopefully,
yeah.
hopefully it comes back. Oh my gosh, where is the share screen? Okay, here.
All right, cool.
So can you see my screen now?
All right, yeah, there it goes. All
Okay.
right, so yeah, let's open up the PCAP so we can see
Um,
what else happened
This one,
there.
I mean, I click on the adapters one. I don't
The
know which one else
LWF.
do you
No,
want.
let's open up the LWF one, the one that says LWF, and let's look for the one with the highest size.
Uh, this one then.
That one, yeah. All right. Now this was a packet capture taken by the client during those events, right?
Mm-hmm.
So we have about 10,000 packets there. So what can we do to filter this up? Any idea, Tim?
I don't know, like look for something here.
The
I
IP
think did
address.
someone said Zoom? Sorry, also. Well, the IP address could be another one. We do have an IP address from the client connector logs, right?
Yeah, the IP address, to resolve the IP address for the
All right, yeah, let's do
Zoom.com.
that. Let's do that. You have that one there from the logs,
3.80.
I'm sorry, are you talking to me?
Yeah, let's do the
Oh yeah,
search by
someone
the
shared.
IP address. You have the IP address also?
Someone share in the chat.
Oh, okay.
Awesome. Yeah. Good. And yeah, and everyone, right? At this point, and guys also, right? Don't feel like this is just one person here sharing and that's everyone else watching. This is all of us working together, right? So feel free to all share your ideas, talk it out. Again, this is the intention of all of this is that we use it as a sandbox environment to learn how to troubleshoot this, right? So this is yours, right? It's just that we have only one screen, right? But all right.
Yeah.
So yeah, let's do it's AP dot ADDR and then equals. Yeah. All right. Then you can hit enter.
I did. I don't know if it's maybe
All
slow
right, there
here.
it goes. Yeah, it takes a little bit. All right, seems like we have nothing there from that one. Was that the same file there? Let's see.
Oh, this is
Is that it?
LWF, right? We open
Yeah,
the
but I think
LWF.
it's a different size than the one that we see in yours, right, Gino?
Let me double check on it.
What was the size of yours? Also,
It's
oh, I think we're seeing
3.5
different
meg.
back here. I
Maybe
think we're seeing a
the
different.
second
I think
one.
we're seeing different logs. I think we're seeing different logs, right? Is it the same folder? Is this the one from exercise? Oh yeah, it's exercise too.
Two.
Yeah.
Is there any
All
other
right,
ones? No,
so
that's it.
it's interesting, right? And it's the only. There should be only 4 of them. All right. Let's open up the adapter ones and see what we got there. The one with 3 meg something, 3.18. Yeah, let's get that
I
one.
had
Let's see if we
this one.
got something there.
Did you want this one or this one?
The second one, yeah. This one. All right, let's check it out there again. Or let's check on that one there. I was pretty sure it was on the LWF. Maybe I
No,
missed it.
maybe I have
No,
the
it
wrong
should be
IP.
on the other one. Let's do one thing. Let's look for Zoom. Let's do on the LWF frame contains Zoom. Because I'm pretty sure it should be on the LWF. Yeah, exactly. There are DNS requests in the LWF pcaps for Zoom. Let's see.
I checked for DNS. There is no entry.
Okay. Let's do instead of IP8, let's do frame contains. Frame
Equal
contains
or
and be no, just frame space contains.
no? It
And
won't.
then no, it will take it once you finish, don't worry. Then in between quotes, just use Zoom. Because
So there's
so here we
Google
go, right?
DNS. Okay. Is
And
that the IP that I have?
why we didn't see the IP when we were seeing the request? What do you guys
Let me
think
see.
that is?
See, is that the same IP?
Yeah, 380.21.32.
Oh,
But
it's not
it's not the
resolving.
destination. That's the
Yes.
thing, it's not the destination IP, right?
Uh-huh.
And we don't see it because we are bypassing the IP address,
Right.
right? So it's not seen on the lightweight filter. It's like, hey, do you see this one? Yes, it's found in cache. Remember? That's what we were seeing on the logs. The first resolution, the bypassing cache, and the bypassing cache. But it seems like the third one, it's now giving us different IP address, right?
Yeah.
And that's where the bypasses stopped working, and we now see the Zoom traffic over the lightweight filter. So we created a VPN bypass that will be resolving the hostname and create a static IP for the IP address, right? And that eventually, if we're doing that for an application like Zoom.com, might change with a different IP address. And at that point, the bypass that we expect to have, and that's why we weren't seeing things like a client hello in here for this IP address, we now see it because it's no longer bypassing the traffic. Make sense, Tim? Any questions?
But there is an option for Zoom and Microsoft Teams, right? This will occur sometimes.
That will be actually for Tunnel 2.0. It's the application bypass. That it's definitely recommended when we're doing Tunnel 2. If we're not doing Tunnel 2, then most likely this will be a pack file bypass, right?
Yeah.
For the app profile. All right. Thank you, Samira, for sharing your screen there.
No problem.
Cool. Any other questions or anything else from anyone about this exercise? Is it clear how we found out the information, what we're looking for, the keywords that we start getting from there? All right. Not really sure if that's either that we're good or I'm not sure, guys, how we're doing with the exercises and with the material in general. I know this might be feel like too much for 1 week. I just want to make sure that you're not feeling overwhelmed or that you're not getting lost on the content.
So does
That's
that
a lot
mean
for
there's
following along.
okay.
All right,
Um,
go for it, Mijo. Yep.
so does that mean like the Zoom.com traffic is still be routed through the ZCC even though it bypassed the rule? Kind of.
Yeah, it basically means that the bypass that we're creating is gonna
Uh-huh.
be based only on that IP address, right? So once the IP address changed, then that bypass is no longer applicable, right? That's
Okay.
what's happening here. Yeah.
That's what we use DNS. Okay.
That's why we use the back files where the browser will be doing that more dynamically, right?
Okay.
All right. Okay, team, let's go through the third exercise. In this case, we're having a customer that's telling us that they're having some firewall errors. And that's actually pretty much a notification as the one that you saw from my client connector previously that was showing the proxy chaining. It shows firewall error on the client connector. I shared those logs also on the chat, so you can download those logs. Um, Let me see who can help me share that. Again, let me see who hasn't shared their screen yet during the week. Let me see. Bhupinder, would you like to go for it? I think you already shared something, but if you want, would you like to help me out?
Yes, yes, sure. I can.
Awesome. Thank you so much. So yeah, let's take a look at those logs. It's on the chat. Yeah, it should be there. It's actually says lab number 3, and then right after that one, it's the file. It doesn't have the name of the file. That's why I put the message, and then the file is afterwards. But yeah, it's the one that started with 2020 12/14/09. Just FYI, guys.
This one, 20, 12, 14, 09, 35, 14.
Yeah, that's the one.
Okay, which file you want me to open?
All right. Well, let's uncompress that one.
Yes,
Also, I
it's
think, yeah.
uncompressed.
All right, cool. Now, usually what I do when when I need to look for or when I need to use any other platforms, well, Notepad++ will be our best option for sure, right? Where we can remember finding files. So we can start just looking using that kind of information, right? So in this case, let's recap what is the whole issue here. It's a firewall error, right? So we may start looking into something like that as well from the logs. So well, if it's already uncompressed, let's just go ahead into Notepad++, go to search and finding files.
Okay.
There we go. All right, there you go. And we can now start using some keywords to search in here, right? Let's see, what can we use for this lookup?
Policy.
All right, we may use firewall. Yeah, that's right, Marcus. We may use firewall as well. That's, I think, also we can use FW because that's also the error that we're getting. But let's see what we get out of firewall. Okay. Now you can expand on that one or just scroll down. All right, we have some firewall block errors here. This is from the CSA tray files. And you see that we have a constant error here about that, right? Now, This is again helping us out to understand what are the files that can help us to look into this information, right?
Yeah.
All right, because this is the tray, it might not gives us a lot of information, but we may also see what other files are showing logs about firewall, because we see the tray, right? But is there maybe any other one? Let's scroll down a little more. You can also grab these from here and just take it up so you can see a little more of it.
Okay.
Yeah, there you go. Yeah, let's scroll down a little bit more. Also, we can grab it from here so you can make it faster so you don't have to go page by page. I know that can be a lot, and it seems like there's a lot of files. Okay, it seems like mostly everything it's a CSA tray. Also, you can collapse each file or each search with this minus. Just clicking this minus, and that basically collapse that search for that folder. So that makes it easier too. All right, we have some CSA tunnel logs too that talk about the firewall block error as well. All right, let's click on that one. Let's click on one of these, and that will take us to the first one here. So you might want to take this one down again. All right, so I see, Shiv, you have a question there?
Yeah, there is no file for lab 3. I'm just checking which one are we supposed to look at.
It's the file named cscaler 2020-12-14.
Oh, the one that has the log files in it, right?
It's the one when it says lab number 3 and right below that one, those are the logs for lab number 3. Yeah.
All right, let me check. Thank you.
Cool. All right. Okay, so let's see. What do we get there? We see the firewall block error. Anything before or after? Let's see what else we get. Or, well, we actually see that it's constantly happening, right? So we see the error. Anything else that might be constantly seen? Let's maybe even keep scrolling up and down. Well, let's see if we got something else there.
Yeah, connecting to
3 out of
TCP
3.
Echo server.
Okay.
We're not trusted.
All right, we're not trusted. That may not necessarily mean that we're gonna get blocked, but at least, well, that's the network type, right? It's on a non-trusted network, but it might not mean that that should be blocked. But we see constant firewall block error. We see the 3 out of 3 and that TCP echo error. Now, let's now that we see a little more of this, right? Let's also do some research and the help documentation, and let's find out what else we can see about the firewall blocks or about the firewall requirements. So let's open up a browser and let's look for Zscaler firewall or firewall errors or CCC firewall for Zscaler. Okay, well, that one is from community. We might want to look into links from the help documentation, right? So we have the status errors. Now, you see that we're getting a lot of noise around that, right? So let's do one thing. Instead of putting Zscaler in front, let's just put site column zscaler.com at the end of your search. Space, no, let's do, no, space, space, type the word site.
Site.
No, SITE.
Okay. Site.
Then column, and then zscaler.com. There you go. All right. All right. Now you see that all the results that we got out from zscaler.com, right? And if you continuing down below, there's one that I like to show, which doesn't seem to be here. And it's about the firewall requirements. Because look, because we're looking at the block error. You may want to look also for firewall requirements on Zscaler or site column zscaler.com. You can leave out error, but yeah. Firewall requirements, CCC, those 3 keywords should be okay. Yeah. Okay, the one I'm looking for is this third one, the allow list. Yeah. Let's take a look at that one. All right, so we have the allowed processes for Windows, Mac OS, and Linux. We have bypass for firewall, right? And let's take a look at this node over here. So it says that 164 is part of the internal health check, right? Do we see that on the logs?
Can I do a search with this one?
Maybe not the /16, but an IP on that subnet range, right? Maybe not
can actually
00
see it.
because that will be the subnet IP. Yeah, you can actually see it on top, right?
Line
It's
32.
right there. Yeah.
Yep.
So you see the 164.06 right here,
Oh,
and
so
we
it's
have
failing
it
open.
right in between all the firewall block errors, right? So let's just look for that IP address and see how many times we got it there. Pretty sure it's gonna be appearing all over the place. Right. You can do it just in the current document, but yeah, that's fine. Okay.
544.
Right.
It's a lot.
There you go. So it's basically all over the place for that connection, and it seems to be the one that it's getting blocked. You can also go check the firewall logs from the client side, right? Or ask the customer to check on that and do this kind of verification. But just with the log that it's telling us this information, and if you scroll down, you'll see it repeated multiple times with the same IP and the exact same lines in between. You see it right there. It's here as well. So you'll see basically repeated over and over again. And that's kind of like part of what we'll be sharing with the customer and telling them, hey, you see this, let's check on this documentation. And this seems to be the cause of this problem, right? Or at least let's rule this out before we continue with anything else. All right. Make sense, Tim? Any questions? Now, this range is also used for many other things. As it says on the documentation, it's also used for CPA. So you may see that it's not just 164.06. You see that it now changed to 03, for example, here. It is within the range of that /16 subnet, right? Any questions? All good? All right, all right. Okay, team. So we've had a very good conversation about troubleshooting the client connector. I think this is very, very important to understand how all of these communications works. And hopefully we have had a good combination between hands-on and and lecture overall. We still have quite a few things to cover. So we'll be leaving exercise number 4 on hold for now. And we'll be going back to that one, maybe on day 5 as a follow-up exercise for some of the things. So hopefully you guys can recap on that one and not pushing everything all at once. I think with these 3 exercises, we have had more than enough fun for at least a few minutes, right? So the next part or the next section of this session will be day 3 slides. We'll start with authentication and provisioning, where we'll talk about the different traffic forwarding. I'm sorry, the different authentication mechanisms. We'll be deploying SAML, and again, if you haven't have created a Okta developer account, let me see. Samir, lab3, it's the file. I'll be sending the file again. Don't worry, guys. I'll rename it when I send them back. But yeah, it's the one that doesn't have the name on it. It's just the file there.
Yeah.
I'm resending it
So,
there.
so, so
But
Davis,
yeah, just
I'm
FYI.
facing issues in creating the Okta dev account. I tried multiple times, but it's giving me 403 access forbidden error.
Oh yeah, I've seen those kind of things lately, uh, and it seems like it's an Okta thing. So I've seen that if you contact support, they will be resetting that connection or basically linking your account with the tenant. But I'm not really sure if it's they doing that on purpose or if something is failing on their side. But during the last month or so, I've seen those kind of things. That's why I'm not kind of like pushing you to go through that one. If you want to use anything else like Duo, go for it at this point, because I've seen that with Okta. So you basically need to contact them and tell them, hey, I'm having this error, and they will be giving you that one there, right? So just FYI, yeah, I've seen that happening lately with Okta, and not really sure what's going on with that. If you have a Azure account or if you want to create a Azure test tenant, Duo also will be an option. Again, any IDP you want, you can create the account there for later testing. Remember that you're going to be sharing also the accounts. So you may not all have to create those IDPs. And even if it's, and also you don't have to at this point, again, because of all the restrictions that we noticing, we'll be doing a few exercises around that will help you out with that as well. But if you can deploy it, of course, it will be better. Now, how about we go into our second break? Since we're still about 2 hours from our session. So we can have about 25-hour break before our last hour and a half. Sounds good?
Sounds good.
All right.
Sounds good.
Thank you so much,
Yes.
Tim. I'll see you soon. Great work from everyone about the exercises. Thank you so much. See you soon. All right, team, we are back from our second break of the day. Now let's please raise the hand to check on the attendance, or once again, just let me know in the chat so we know you're back. All right. Excellent, team. Thank you so much for being back on time. We'll now gonna get back into our session. I don't think I've shared the slides for day 3 already. Let me see. Nope. Let me share those slides here just a moment. There we go. All right. So we're going to be talking about user authentication. So far, we've talked about the architecture, traffic forwarding. We um, took a deeper look at the client connector, which is one of the most important aspects of the communications. And now we're going to be talking about user authentication. So let me share my screen here. There we go. So in this section, we're going to be talking about user authentication and provisioning. Our objectives are that you guys can explain and describe how authentication and provisioning works, the user search and group search while doing LDAP authentication, what's the difference between cookie-based and digest authentication, as well as explain the concepts around the SAML authentication and the usage of multiple IDPs. You will have a quick view here of a guide in case you need to integrate Azure or Azure AD, just as a reference for you guys to have there. Now, the two key parts that we need to talk, it's provisioning and authentication. We briefly discussed about this on day 1, where we talked about the difference between provisioning and authentication. So we need to have all the user groups and departments provisioned in Zscaler so we can enforce the policies that we need. After the users are provisioned, then with the correct identification, like either a challenge for a password or receiving things like a SAML response or Kerberos ticket, we will be authenticating the users. Now, remember when we configured the IPsec tunnels, we needed to create a location. A location could be a representation of a physical place, or it could be just things like a destination port that identifies the traffic as part of our organization. So we can have things like just a static IP address provisioned, VPN credentials, GRE tunnels, dedicated proxy ports, and the use of the virtual service edge or private service edge. The authentication can also be enabled or disabled for a specific sublocations. A sublocation is a subnet range that will be defined on that location that will represent a specific VLAN or traffic coming from a resource or source that needs to have some sort of bypass or different kind of treatment of the traffic. For example, guess Wi-Fi traffic, right? That kind of traffic will be bypassed from SSL inspection, will be bypassed from authentication, so we don't impact the experience for those users. We represent the sublocation with a subnet range. For example, in this case, we are representing the subnet range 10.00.22, I'm sorry, 10.10.22, all the way down to 10.10.22.50. So if I want to create a second sublocation that includes any IP within this range, then I will have to configure a 2 separate ranges, or actually 3, so it can get the IP address usable. We cannot have IP addresses that belong to a specific range on another sublocation. Now, Zscaler is a close proxy, meaning that we are going to be, or we need to know who the user is or the company that's passing the traffic through the service. So with these options, we can either check on a local database or we can review against a already existing database like a LDAP server. Some of the methods that we have for that, once again, hosted DB, we create it manually, we use a CSV file, or we use SAML auto provisioning and skim, which I'd like to take a moment here to talk about these two mechanisms because they're usually overlapped in regards to the concept that we may have about it. And I'll just want to make sure that we are completely sure about the difference between those two. So when we're talking about SAML auto provisioning is the action of creating the user on the database, is not the act of the SAML authentication. We use the same source, we use the SAML response, but this is used to create the user while we authenticate them. Does that make sense? Yes, no, maybe? Tim, just want to make sure that we know the difference between SAML auto provisioning and skim. Again, it's going to be very important when we're dealing with a customer case because we can still use SAML authentication while provisioning with skim, right?
Yep, got it.
All right. Cool. So with Skim, as we may know, it's just an API call and it's a real-time change. We can delete users with a Skim provisioning mechanism. We'll be configuring SAML auto provisioning in Skim. Most likely first SAML and then Skim. With Active Directory, we need to have an inbound connection from the central authority to the Active Directory servers. So as you may see, this might not be one of the preferred methods, right? If we can have some sort of integration like SAML, we don't need to have our AD servers exposed with any kind of inbound rule. If we don't want to have the inbound rule, we still want to have the AD servers, we can use what's known as the Zscaler authentication bridge. It's a virtual machine that's installed on the customer premises and is used to create an outbound connection to the central authority instead of an inbound from the CA to the AD server. Now, as we were talking, cookie-based versus cookie-less. Cookie-based, anything that has to go through a browser, and we can use any of these type of authentication mechanisms. With the cookie-less authentication, we can use things like Kerberos or digest authentication. That's mainly seen with the client connector. All right, now here we have a example of the authentication that's happening through the cloud when we have a hosted database authentication. We'll take a look at this, and I'll also gonna be asking you guys to follow along with a demo that I'll be going through while we take a header trace and we'll see what are the components involved in all of this, all right? So we'll be basically toggling between this graph and the Windows machine. So initially, when the client is intercepted, or when the client traffic is intercepted, will be landing on an SME, right? That SME will receive the request for the domain in question. And if the SME does not have a way to identify the user, it will be redirected to the gateway domain, which is also on the SME, in order to first test out if it can handle the cookies required for authentication, and then later redirect them to the central authority for the actual authentication. So let's take a look at this path and how that looks like on a header trace. So for that, let me bring up here the virtual machine. And instead of the client connector, I'm just gonna turn it off for now. Because remember, the client connector uses digest authentication, and I don't have it as enforced proxy. So what I'll do is that I'll just change the proxy settings on this machine. To point to, in this case, Zscaler 3. So I'm gonna use that one just for testing. You can also use gateway.zscaler2.net. That will resolve to the closest data center available according to your location. That it's still gonna be, if I'm not wrong, Washington. Now there's another tool that's pre-installed on these machines that I would like to show you, and that is this plugin called Switchy Omega. Let me first of all clear browsing data here so we don't have any issues. And this is a plugin that will allow us to either bypass the traffic completely from a proxy, use the proxy settings that we have on our machine, or use our own profile, right? So you can go to options and click on new profile to add a HTTP profile and basically point out to the exact same domain that I was referencing to. All right. Now, in my case, I'm just going to be using this one, but again, it's the same thing. So we'll go into the three dots. We go to more tools and developer tools. Now, on these developer tools, make sure that you have this option enabled, preserve log. If we don't have this option enabled, then after every redirection that we have, we just get the logs are gone, are cleared out. So make sure that the option preserve log is enabled, okay? Seems like I have some sort of filter there, no? Nope. All right. Now I'm gonna go to, let's go to portquiz.net. I mean, it seems like it didn't challenge me for authentication. Why is that? All right. It seems like somebody else it's provisioning that Zscaler IP, and I'm going through their tenant at the moment. Do you guys see something similar? Do you see, or are you able to see there? Hey, Tim, you with me?
Got different
Well,
error. I got 08100.
all right. The tool that we were showing, it's a plugin that's pre-installed. It should be there already. It might be hidden, so you might just want to put a pin on it, but it's called Proxy Switchy Omega. It's just a plugin that allows you to toggle the proxy from the browser. Awesome. All right. So it seems like I'm gonna have to reach out to Gabriel. Let me see which Gabriel is it. But I'm gonna have to chase someone here to help me out with this. Nice. There's like 4 of them. Let me see. Might be this guy. Okay, cool. Let me get this IP. Oh. Okay, 1 second. Sorry, Jim, about that unexpected result there. All right, there we go. Okay, I'm gonna have to wait on this guy to respond back to me. In the meantime, what I'll do is that I'm just gonna change that to Zscaler 2. It might redirect me with a little different option. Or actually, you know what? Let me see. Can anyone I'll stop sharing here. And anyone can help me out, maybe sharing your screen and showing that part out. Who hasn't shared at the moment? Let me see. Tucker, would you like to help me out with this one?
Yeah, I can share. What do you need to see? Just the IP.zscalers screen, right?
No, we're gonna be basically taking a header trace while we do the user authentication, but we're gonna be breaking down each of the steps of the information that we see.
Okay.
All right, so let's do a couple of things here. Are you currently going through Zscaler, right? Is that using the client connector?
No, I turned it off.
All right, nice, cool. So let's go back here and let's do first one thing. Let's clear this out so we don't see this first part. And should be challenging for authentication, right? So let's go just to port quiz. That should be challenging the connection for authentication. All right, so there we go. So before we continue here, let's right click here on this column and we'll enable the option that says remote address. That shows the proxy IP address. All right. You can also click here 1 second so you can expand to the full screen. You can click here on this chevron here. 1 sec. Here on this option on the top of the window, yeah, the gray one.
I have a question
Yeah,
about
that
this.
one there.
So we're being
Yeah,
prompted
that
for
one.
authentication, right? But what's triggering that?
Mm-hmm.
Because if we
The
have
proxy.
internet turned off, oh, did we set a manual proxy? Did I miss that step?
Yeah, we set a manual proxy.
Oh, okay.
Either with
Sorry,
the
I
proxy
missed that.
settings or with the plugin, yeah. So cool. Yeah, no worries. So yeah, we're basically sending traffic there to the proxy. And as we see here, we are being sent to the virtual IP, but the one responding this information is the SME. Let's click on one of these packets just so we see the one that's responding back. Let's double click on it. Also, I think it's here. Maybe sorry. There it goes, yeah. So we see that this is a get request to port quiz, and we're seeing a redirection to gateway, right? Which is what we're seeing here. If we I will be coming back to the flow in just a second, but this is basically telling us that we are redirected and tested for the dummy cookie just to see if this transaction can be handled. Now, if you input the username and password for your cloud. Let's try to log in there. Should be also one thing there. Go back to network 1 second. And let's close this part. There it goes. Now let's go ahead and input the credentials there. Error 081,000. I'll see if that's maybe it's the same thing that I'm seeing. Let's see. No, mine
It's
it's showing
.com,
only.
right? Sorry,
Not
not
that
.net.
net. Yeah, that net. Oh no,
Oh,
sorry. No, the domain is .com. The domain is .com. Yeah. I was thinking about the cloud. Sorry.
yeah, me too.
All right. So yeah, the password there. Now, because the user is locally created on the database, the same central authority is the one challenging for authentication, right? All right.
Yeah, I forgot my password. 1 sec.
No worries. Right, let me go back to the flow here. We will just while you log in, so we can recap what we just saw on this scenario here. So excuse me here. There we go. So what we just saw here is that the user was trying to go to portquiz.com or portquiz.net, and well, portquiz, and they redirects us back to gateway, and they tell us to insert the cookie. Then we get the login form, right? That login form, when we are sending it back, is going to the central authority where we're submitting our username. Because it's a local database, we don't need to redirect the user to an IDP or anything else. Then the client will be sent with the password form so they can submit that against the central authority. Once that part is complete, the central authority will bring back the client with a ticket that will be used to create the tokens and the cookies that will be used for the authentication and for user redirections. Now let me stop sharing here. Let me know if we can continue there just to finish checking on that part there. There we go.
Yeah, I'm good now.
Okay.
All right, so we're gonna log in.
There we go. Yeah, let's log in.
It. You just updated it.
Oh, you need to activate.
Oh, right.
Always happens to me too, yeah. There we go. All right. Now, if we go back here to this traffic flow, let's just double check what happened here. So these are basically the password attempts that you tried, right? So all of these are post messages that contain the actual password. We can actually see it if we look into it. Then after the authentication was performed, we see a couple of lines right here, right? One is for gateway. Let's take a look at this one right here. All right, now if you scroll down, it might tells us let me see, I want to see if we have the expiration date of the cookie. Because we have the one for the domain cookie, but it might not be because if it's let me see. Scroll up here 1 sec. Might be the other one because this is going to this is the right direction. But where is the request going? Can you go to the top? 1 second. It's going to port quiz. Let's go to the second one, to the other one. It should be going to gateway. Yeah, that's the one. So if you scroll down there, this expires on September 18 of 2026. You see? So 2 years from now, right? We'll talk about this. This can be this date. It could be just a value that can be hashed by the SME, and or it could be a specific time frame that we have, or 30 days. So this is something that we're usually going to be taking a look at when we're doing cookie-based authentication. It's not widely used because most of the time we're going to be dealing with the client connector, but at least something to keep in mind. All right. Thank you so much, Tucker, for sharing your screen with this part of the exercise. All right. Now, for the LDAP authentication, things are a little similar. Let me see. I'm getting the same error, 081,000 forbidden. You mean from the page, right? After authentication, guys? Mijo, can you share your screen just real quick?
Yep. 1 second. Let me turn this off. And share. Oh, stop sharing. Can you see my screen?
Not yet.
Okay. Maybe I need to do like this. And I share again. Oh, this one.
All right, there you go. Yep. All right. So yeah, it's give me a let me see, because this seems to be also somebody else's account. So let me get
Oh yeah,
this
mine
information.
has Shandon's logo.
All right, let's see. Is that your organization ID? Just to double check. Can you check that on the admin portal? You see 2476? Let's go to the admin portal 1 second. Let's check on one thing. I want to verify one thing first. Let's yeah, go to admin.zscaler2.net. I think it might be the first tab you have there already open.
This one.
Yeah. Yeah. All right. Now, if you go to the administration and go to company profile on top, not at the top. Yep. All right. That's your organization ID, right? 2476, correct? That matches with the one we're seeing on the error, correct? Can we take a look?
Yes.
Yep. So let's see what's going on here. Let's take a look at that admin portal. And let's see the current authentication parameters and also the location maybe that there's traffic it's coming from. So you see that's the company logo, right? You can delete it if you want, but yeah, that's basically what we're seeing there.
Oh, okay, so you can upload company logo. Okay.
Yeah, that's why we see that customization there. That was from a previous bootcamp there. All right. Now, let's see. Let's go to administration and user no, sorry, user authentication or authentication settings, I think. Let's take a look.
You say go to user administrator,
Administration and
user
authentication settings. Yeah, authentication settings.
authentication
Yeah.
setting.
All right.
All
So
right.
let's see. We have form-based authentication, which is good. And we have hosted database. That's what I wanted to look for. This is telling us what kind of provisioning and what kind of authentication methods we're using, correct?
Okay.
So let's see what else we got here. We see, let me see this. Go to the administration and go to location management. I want to see if there's any locations created.
Administrator, location management. Okay.
All right, seems like we have a couple of locations. Let's move that to the left. There it goes. Okay. All right, so those are just for the VPN credentials, right?
Yep, this is just the check. Yeah,
And that's using only the VPN credentials, right? And we're using that with the Ubuntu machine, not with the Windows machine. So all right, this is interesting. Let's see. Let's open up an incognito window with the proxy settings on, or I don't know if we can clear the caching cookies from it. I would prefer just the incognito window and change the proxy settings. And let's take a header trace from scratch and see what's the whole experience there. So first, let's go ahead and change the proxy settings on the machine. So go to Windows and type in proxy. All right, now we use a proxy server at the bottom. And we put gateway.zscaler2.net. All right, now let's save that.
is it port 80?
Yeah, we're gonna leave port 80 for now. That's good. We don't click on save, and now we'll come back to that incognito window, and we'll open up the developer tools. All right. Yeah. Once it's saved, it doesn't actually tell us anything. So yeah, we're good there. Now let's open up the dev tools first before we start browsing. So go ahead and yep, that'll be more tools and dev tools. Yeah. All right. We go to network. We click on preserve log. And let's try to go to port quiz and see what do we got. We should be getting the challenge for authentication first, right? All right, this is interesting. It's basically not challenging for authentication at all, right? Now, let's go higher up and let's go to ip.zscaler.com. I would like to take a look at where is this traffic seen from. All right, seems like we have a user there.
That's me.
All right, do we have the, okay, we have the client connector on then, right?
Yeah.
Yeah, let's start it off. So we can test with the proxy.
Mm. Yes, they open a one shot.
Yeah. It seems like that might be part of it, right? Samira, I'd like to check if you did that similar check like yours, or if you're seeing very similar thing. I'd like to
I was trying
double
to
check.
follow what you're doing with him.
And
Mine
what kind of
was
error
saying
you're getting?
mine was saying status code forbidden. Same thing when Chandan is the organization, which I don't recognize, but I'm trying to follow the changes that you're doing
But
with him.
it doesn't challenge you for authentication when you try to go to port quiz?
Let's see. It didn't challenge me before. No. Let's see
And how
again.
about now with the incognito window? Yeah, seems like we're only seeing the browser, but
Yeah.
yeah, it's kind of like
I'm
it's
gonna do a
offline.
continue to site.
All right, so it continues to the site, sorry, or challenge for authentication.
I had to click continue to the site.
All right, that's maybe because of the HTTP. All right, but I like to see
Yeah, because
maybe
it's not
there's a
secure.
policy. Maybe there's a policy also blocking that. We may need to see if there's a URL or cloud control policy there. But okay, for now, I like you Mijo, to we turn off the client connector, right? It's off at the moment.
Yes, sir. It's off.
All right, it's off. Excellent. Now we see CPA as well. Why we see CPA on that account? All right, I'll check on that. So I think we're gonna have to close this one and open up a new one, but because this is basically just gonna cache the response. So we're gonna have to open up a new incognito window. Because mainly with such a simple website, it's not gonna be keeping
I
that
think it's
there.
working now.
All right, yeah, let's take a look. I want to see how that behaves now. Right, we should be challenged for authentication. Let's go to ip.zscaler.com. All right, seems like the proxy is not taking effect. Let's take a look. Maybe the client connector removed that config. That's totally expected. Let's click on save again. And let's go back to the app. And again, we might need to close. Sorry for that. It's unfortunately how the browser works. So let's go back to the browser. Because the thing is that the client connector will override this configuration. We may not have seen it because we didn't toggle between anything else. But when you save it, the client connector went back and changed it again because they're the one intercepting the traffic, right? Or even might not be applicable because it might be doing it at layer 3.
Does
So
it look correct?
at this point,
Gateway Z
yeah,
SC.
gateway dot scalar2.net. Yeah, that's the correct proxy.
Yeah.
Let's click on well, we click on save already. And now let's go to port quiz again, but with the developer tools open. All right,
Oh,
we get the
it's
challenge.
working.
That's good. All right. Let's go ahead and enter the credentials for the user.
GI dot
That's
what's the
bootcamp8.com. I think it was bootcamp 8, right? Let me see.
double check
Oh no, you were in bootcamp 1, right?
okay.
Boot camp 1.
Yeah, you're
Student.
bootcamp 1. Yeah, you're with Marcus, you're right. Yeah, that's I think okay, right? The username it's all right. Yeah. Okay, you copied everything. Okay, cool. All right, let's click on all right, the ad. Let's click on sign in. All right, there we go. We're good. There you go. Yep.
Okay.
And we see
Yep.
the Zscaler's IP address, right? Yeah, it was just a client connector interfering with the two connections there.
Okay.
All right,
So
all right.
authentication
Awesome.
for local. Okay, thank you.
Cool. Let me see. Samira, how about yours? You're seeing something similar? Are you
I
getting
was, but I
similar?
think I got it. Not sure. Let's see. I think I did get it now.
All right, awesome.
Because I was getting out the authentication before I was getting, hold on. I was
And then we
getting,
see the 165 IP as well there too. Right, you can go to ip.zscaler.com, that bookmark here. That will let us know if you're authenticated or not, or what's the current user that shows up. Yep.
yeah, I finally logged in.
Cool. All right. Excellent, team. Thank you so much for going through that part. And once again, that helps us out to see a little bit more about the overall authentication process. With LDAP, things are a little different because the database is not on the central authority. In those cases, what we do is that the central authority will be sending a bind request and expecting a response from the LDAP server. That's why we need to have an inbound rule that allows the central authority to connect with it. Otherwise, we may need to have the Zscaler authentication bridge, which is a VM that will be making the connection outbound. But in this case, in the default behavior, when the user prompts the login form, the bind request will be the one with the actions there. And the user authentication with the user search as well, where we'll be then bringing back the ticket, the token, and the cookies to be created. Now we'll be taking a look at this communication here a little more and in a couple of sample pickups in a couple of upcoming exercises. But overall, the end user experience is actually the exact same thing. Now when talking to LDAP, a couple of things to keep in mind. We need to have the domains provisioned on the Zscaler account, and we need to have also access inbound to these AD servers. During the search filters, we're going to be doing a user group or advanced search filters that will help us create those either provisioning actions or authentication actions as well. Some of the attributes that are synchronized are the user principal name, display name, and again, depending on how they look like on the Active Directory environment of the customer, we may need to adjust according to the exact name. Now, this is an example of the advanced search filter. Notice how we're looking for this specific user, right? And that will bring us back just one single response. We may do this kind of search filters with wildcards, which may eventually bring us some problems when configuring or when connecting with overlapping users. Here is also by type of filters, either email or user, using the UPN. Now, this is the other type of search filters that I was talking about when the when the advanced search filter is not configured or is not configured properly. We're gonna have these kind of lookups where a user type in this information, but there's a couple of wildcards on the search filter. That means that we can end up having overlapping users like Joe with A and J Joe or so on and so forth, right? So these kind of things are what can trigger situations where the user it's putting their correct credentials, but they're receiving a error telling them that their credentials are incorrect. Any questions so far, team?
Yeah, how do you stop that? I mean, I get why
We
it's
can
doing it, right? But
Yeah, at that moment, yeah, we'll be basically configuring a different type of search filters, like the advanced with the specific settings like this,
Oh, okay.
because
I just need
otherwise
to
they
wait.
will be, yeah.
Next slide. It's okay. I can wait.
Yeah, no worries, no worries. Yeah, yeah, that's basically the ones that they will be using on those scenarios, right? And you can configure that. There's a few documentations as well that talk about all of this and talk about best practices and that kind of stuff, right? So you can definitely go deeper in that part. All right. Now, one thing also to keep in mind, I don't know, in that something that you guys maybe help me out to respond. How much of LDAP do you see nowadays? Not talking about Azure AD because that's SAML, right? But LDAP integrations, do you see many of them nowadays, or is a rare occasion where you have to troubleshoot something like that?
Rare.
It's still there, but it's not as prevalent.
Right, right. Yep, yep. That's kind of like what I wanted to highlight, right? With a service like Zscaler, usually having this kind of LDAP integration won't bring me but much more benefits than what SAML may bring to the table, right? So ideally, I will be doing a SAML integration rather than having to do a whole synchronization with my LDAP servers, right? But yeah, it might still be relevant for certain type of cases or even certain type of organizations for sure.
Yeah, we have some customers that may not have budget to move to something in the cloud, and they've already got the existing on-prem stuff. So I mean, we see it. It's just, like it was mentioned, it's not very prevalent, but it is there.
Correct. Yeah, yeah, that's right, right? That's definitely one of the factors that keeps people on that part too. That eventually, within time, they will be eventually all migrating. At least that's what I'm thinking with those kind of things. But yeah, yeah, cool. All right, so a couple of limitations that we have with the AD integration. We can synchronize from one forest. If we need multiple forests, we recommend integrating SAML. We can use multiple domains, but all those domains need to have been registered with the Zscaler organization or in your Zscaler account. And we don't support nested groups for these active directory synchronizations. When troubleshooting these kind of communications, the error code will be very important. Also making sure that we can verify the credentials against the AD servers and directly to those servers and also through the Zscaler service just to compare. If the authentication is successful over the AD server but not over Zscaler, it may be a situation where the search filters are triggering an incorrect response. Always testing over the plain text connections instead of the SSL. It's a good idea, at least for initial communication checking and making sure that the protocol works properly. Not just for LDAP, but for basically anything related to SSL communications as well. All right. Now let's see, we have another exercise here about LDAP transactions. So we have a customer's organization using LDAP to authenticate, and these users, or there is a user that's having problems with authentication. They took a header trace on the client side, and they also took a packet capture on the AD server. So we'll be taking a look at that information and let's review it together here. I'll be sharing the files also. I think the file it's only available to open up with Fiddler. That's the only thing that I've seen with that one. So you might so just FYI on that part. Let me see, where did my chat go? Here it is. All right. No, it's a hard file, so you guys should be able to see it. Okay, so I'm pasting that file. And I'm pasting the packet capture here as well, right? Now, how do we open the HAR file? You can just open up an incognito window with your browser and open up the developer tools. And on the same tab that we were working before for network, you may stop capturing because you don't need to capture the data. You just drag and drop the file in here and you should be able to see the information here. All right. There you go. We have the error right there. It seems they're trying to go to Never SSL. They're getting challenged for authentication. We saw this one where we were having where we were taking a look at some of our captures. It's basically when we're putting the password, and we can see the password for this user here, and we see the user as well. So we have our first piece of information, right? Our user, it's called random@avitan.co.in, and they're putting this password there, right? If we go here, we see a error. Let me see, where was it? Was it this one or was it this one? This one. So we see that for random, we're getting the username and or password provided are incorrect. Let me know if you guys can see that on the header traces that on the header trace that I provided, and or you're having any problems opening that part up. Right? You can just do the thumbs up as a reaction, just to make sure that we're all good there. If you need more time, also just let me know.
Can you start from the scratch how you open this file?
Sure thing. So I just opened a incognito window, right, with my browser. Then opened up the developer tools. And I stopped the recording because I don't need to capture anything. And I just dragged the file in here.
Okay, thank you.
Cool. All right. Now we can see the username and we can see that we're getting the incorrect password, right? Now we know this is LDAP, so we can just tell the user, can you check against the AD server and see if you're still getting the same error, right? In this case, they went through it and over the AD server, everything is working. So we need to check on the packet capture that it's showing us the communication between the central authority and the Active Directory. All right, we have about 600 packets here, a bunch of TCP connections there, and what can we do to filter these out? Any idea? Let's see. Survey? Any idea? What can we do to filter these out? All right, let me see who else we got there. Amruta, you there? Not sure if Amruta Pisal Deshmukh. Not sure if I'm saying correctly. I'm sorry. Are you there? Can you hear me? Maybe you're double muted. All right. All right, all
Well, we know
right.
what port
Team, remember?
LDAP runs on, right? So we can just filter for the port.
Yeah, we can do it for the
You could
port. We can
just
also do it just
filter
for the
for
protocol.
LDAP.
Maybe we can
Yeah.
filter for
Yeah.
protocol LDAP.
Yep. We can also just do LDAP there. This is basically because I think it's somewhere here under preferences, I think, where you can see all the protocols and where they're mapped. So you can see that LDAP is mapped to those ports already. So yeah, we got here LDAP authentication, right? So let's see what else. We have here a few authentications, right? We have a bind request, a response. We have a few other requests. We have here a response with the invalid credentials, right? So we may want to follow that one. Let's follow the TCP connection for this transaction here. So we see the search request. And remember what we were talking about before in respects to the wildcard searches, right? Now, this is looking for a wildcard, and therefore that response might gives us more than one answer, or that question might gives us more than one answer. You see that we have a random and we have random, and our user was not a random, was actually random, correct?
Yeah, the second one. So it matched on the first one and failed.
Exactly. And then it sent the bind request with the incorrect user, telling us that it has invalid credentials, right? So this is something that we can just modify again from the admin portal. Let me share you here. Under the authentication settings, where we look at the Active Directory integration or configuration, we can define the search filters and basically modify these with much more details, right? Again, there's a few articles that talk more in depth about the process itself, but I like just basically to illustrate how to locate and isolate these kind of situations, right? Any questions, Tim?
Simple enough. Make sure you're matching on something unique.
Exactly. Yep. All right. Now here's just a quick lookup at the authentication breach. This is one of the oldest devices, and as the same as Active Directory being less and less used, the authentication breach is in the same way, even less being used because of the type of deployment and everything that goes through as well, right? So this device, what does is that it creates a outbound connection from the customer's data center, from the customer premises, and to the central authority. That outbound tunnel will allow the central authority to query the Active Directory while having the authentication breach on behalf, doing all the queries for the CA. A little bit of the traffic flow of what happens during this authentication. But as you see from the end user perspective, nothing much is changing, right? All they're seeing is basically the login prompt and their password challenge. We'll be getting more in depth into some more information about these connections or this setup when we talk a little more about virtual machines. Now let's talk about SAML authentication. With SAML stands for Security Assertion Markup Language. It's an XML-based framework that allows us to transfer information between two parties, in this case, an identity provider and a service provider. The identity provider is the one that performs the actual authentication, And in the form of a SAML response, we'll be forwarding the authorization to the service provider. The service provider will be then granting access to the requested service. In our case, Zscaler is a service provider. Although there is a couple of things that we need to keep in mind when we're doing the actual user authentication. Also, Zscaler can work as an identity provider with the help of the mobile portal. Now, as you notice here, the service provider and the identity provider are not interacting with each other during the user authentication. Everything is happening through the client when they either start the conversation with either of the two identity provider or service provider. That's what's known as IDP or SP initiated SAML, which we'll be talking about in just a few slides. Now, benefits of this type of communications. Overall, SAML provides a better user experience, allowing users to authenticate to an identity provider and accessing the service without any kind of additional type of authentication. It also makes it more secure and independent for the application logic. It's more oriented to the service itself. It doesn't have to manage all of those synchronizations between directories. And once again, that provides much more benefits and less management efforts from the administrators. There's no use of TCP and UDP ports, which once again, it's a big advantage that we don't have to specify any kind of custom ports. The once again, SAML provides much more benefits. The reuse of that single authentication overall through multiple applications. As we know, it's so widely used in basically anything that we interact with nowadays. Now, IDP and SP initiated SAML. Those are the two types of authentication that we can observe with SAML. The first option, a user is going to the identity providers page, for example, the Okta login page, one login, Microsoft Azure AD, anything we may think of. And once we log into the identity provider, we can have a list of the applications that will be available for our use. So we click on any of these applications and a new tab is open with the authentication already performed. Because we are already authenticating against the identity provider, we're just forwarding a SAML response from the initiated connection from the IDP. On the second option, this is initiated by the service provider, meaning that the client is first trying to go to the service, but redirected back to the IDP for authentication first. This is the same scenario or behavior that we observed when the client connector is authenticating with Okta or when we have a proxy and we redirect it to the IDP page. Here we can see the traffic flow of that type of authentication, where the browser tries to connect in the same way, and the Zscaler service redirects the client to the IDP. Once we bring back a SAML response, we're going to be using these same mechanisms like creating a cookie or using the digest authentication to then finally go ahead and connect with the internet, right? But the only thing that changes is the interaction from the client with the identity provider. So we'll be taking a look at this traffic flow from a demo in my environment, and then we're later going to start configuring the IDP for hopefully those who have the identity provider there configured. All right, so the client, once again, goes to the domain in question. We're redirected to test the cookies. And after we submit our username against the central authority, the central authority will have the configuration of our identity provider, and therefore being able to provide a redirection that brings the client back or brings the client to the identity provider. Once the authentication is performed, the same thing will happen where we bring out back the SAML response and we use it to create a token and the cookies that will be used by the client. So let's take a look at that communication here real quick. Right, I'm gonna be using Zscaler 2. Okay. Notice how I am bypassing this domain, right? This is a best practice and very important to perform because otherwise the connection might fail. Remember, Zscaler is a closed proxy. So if I'm still sending this traffic over the proxy, I'm gonna get challenged for authentication on that one too, right? So let's take a look.
That was your dev
What's
URL for Okta, right? Is that you're just
exactly, yeah,
exempting the
that's my
IDP
dev
information?
URL. Correct. Yeah, the IDP configuration, it's on the portal here, right? We have SAML, as you notice here, I have SAML as the authentication type. The identity provider configuration is here. We'll be taking a look at this in a few minutes, right? Of course, about what is all of this configuration, where is this URL coming from, and where is it taking us to? We're actually going to be seeing this on the header trace. You see that that's the dev URL that I bypassed. So yeah, we'll be seeing the config overall in just a sec. But just to check on the traffic flow, let's try to go to PortQuiz again just for testing. Yeah, this is an error from the browser. That's expected because it's HTTP and it's not the most secure thing, of course. But we can just continue and we can see that we have a virtual IP and we're prompt or challenged first for entering our credentials, right? So we input the credentials.
So is this page that you're on right now, the sign-in page, is that secure?
Yeah, this is the SME. And the only thing that we're providing here is the domain. And also, until this point, we are now going over SSL, right? That's the
Okay,
first
yep, now I
connection, the one
follow.
that went to, yeah, the one that went to PortQuiz is the one that went over HTTP. But then we get the redirections and we're being sent to this HTTP gateway in port 443. And this is the SME basically. All right, now here, the central authority will check that my domain belongs to an IDP configuration, and therefore we're being sent to this Okta preview. We can see here on the payload, this SAML request. Now, if you notice, this URL that we're seeing here is the URL that is configured on my IDP settings here. Now let's authenticate with this user. Right. Okay, now the page, it's giving me an error, but this is not necessarily a Zscaler error, correct? Yes, no, maybe? Is this an
It
error
came
from
from
Zscaler?
Cloudflare, so
Says DNS
From
is
Cloudflare.
not resolving.
Yep. But it's basically a response from port quiz, right? Or at least when I'm trying to go there to that specific connection, right? So let's just take a look at this part here. After I send or after we enter the credentials, we are sending this to the, or we're basically getting the SAML response. That SAML response is taking us back to the cloud and where we are able to input the cookies that we were talking about. Let me make this one here to the side. This cookie expires October 18, 2024, right? So my authentication frequency is set to 30 days, right? And then we have the connection with the cookies that we have for redirection. So what we're seeing here, it's a basically the representation of what we're seeing on these graphs. All right. Now, for the IDP initiated SAML, we don't support that for the users. We only support SP initiated SAML, meaning that you're either going through your proxy settings or the client connector, but there's no way for you to go to the Zscaler service without actually having to go to the internet, right? We can do that for the admin portal, but not for the CIA users. Now, SAML auto provisioning will make use of the SAML response that we were looking at in order to fill out the database information for the username, the group, and the department information, for example. So that's a very helpful way to automatically provision the users without having to rely on a CSV file or having to manually input the users there, right? Now, here are some of these URLs that we'll be observing. The SFC SSO is the one that we just saw with the SAML response. In the case of the IDP initiated, we'll see that SSO UDP, which we'll be taking a look in a moment. And we only support SAML 2.0 and post binding. That's a few things that we need to keep in mind, as well as the bypass that we were talking about for the IDP URL. Now, we just looked at the header traces and how they can help us out. In addition to that, we can have multiple identity providers on our organizations. We may have multiple domains with multiple IDPs that are being used for maybe merging acquisitions or because there's just multiple brands over the same organization, right? So we can have up to 16 different SAML IDPs. Let's go through how that criteria will be basically dictating if you're going to one IDP or to the default IDP. So a unauthenticated user will try to connect with the Zscaler service via any of the traffic forwarding mechanisms that we saw, right? So the SME will be first taken into consideration if this traffic is coming from a known location or if this is traffic coming from a remote user or with the client connector. Now, if this is from a known location and that location is mapped to an identity provider, then the user will be redirected to that identity provider. But if the location that we're coming from is not having any IDP map to it, we're gonna be redirected to the default IDP. And the same behavior will be observed for remote users. But instead of using the location, we'll be using the domain as the criteria. Now, this graph that we're seeing here on the slide, it's also available on the help documentation. In the about document, I think, about multiple IDPs. So, long story short, location or domain will be taken into consideration to either send you to your IDP or to the default IDP. Now let's take a look at that a little bit more, just so you guys can see how that works. So for example, here you see that I have multiple identity providers, right? We have this Okta, we have this Microsoft.test, and this Azure AD, right? Now, any domain and any location will be mapped to this Okta identity provider because it's the default IDP. But this other IDP is never going to be used, at least for what it seems right now, because there's no mapping to it, correct? The third IDP, it's going to be used by remote users when they're coming from this specific domain. If a user is coming from any location, they're always going to get to this IDP because there's no location mapped in any of these other two IDPs, correct?
So I mean, there's no point in having anything else, right? You'd have to move something up.
Or at least map a location. For example, here, it will be the domain, right? So for example, if I am this user, let me just get here.
Does
We're
it
gonna
not
be
follow
using the
top
same.
down in the order?
No, it's gonna be more specific for that. It is gonna be basically following these criteria,
Oh,
either
okay. So it doesn't
location
matter what
or
order it's in.
domain. Yep, yep, yep. So let me share one thing here. Sec here. I need to look for something. Where is it? This one. It's this one, yeah. So if I'm trying to go to port quiz and I use this user, let's see if it takes it. Yeah. I'm getting to this login Microsoft page, right? But if I'm using this other user, then I'm going to Okta, right? Because here it's based on the domain, right? But if this traffic is part of a known location, like for example, the IPsec tunnel, everything will be going always to Okta, no matter what I'm trying to do. I'm always going to get challenged to Okta. It doesn't even give me the option to enter the user. Make sense?
Yeah, so basically, if you don't match on that domain, you go to Okta.
Yeah. Or the location, right? If any, if there's any locations here, right?
Yeah, okay.
So we can map them here. For example, the vCIN could be an option there, right? All right. So, Tim, here we have a exercise that we'll be following up on as well tomorrow, as well as the exercise 4 of the client connector, just to use as a recap. Mainly because this is the same kind of header traces that we've been seeing throughout the whole day, right? So just one thing to recap from then. This is an exercise that we'll be also checking right now. It's fairly quick. It's basically the same thing that we just talked about, just with a different example, so you guys can see it a little different. So in this case, the organization is using SAML, and they have multiple IDPs, right? A user from a location is always redirected to the default IDP, rather than ADFS, right? And they're showing us their username with the domain in question that when they're going remote, they have no problems. So based on what we know already, it's fairly simple to pinpoint, right? There's no locations anywhere, right? So if you're gonna be authenticating from a location and you want ADFS, then you need to map that location there. All right. Now we'll just go through a little bit more of authentication frequency, and we might be leaving the Okta setup for tomorrow. Then we're gonna be going through the admin portal, but we're still within a very good time frame for the content that we have remaining. As you may notice, it takes a little bit of time, right, just to get to the admin portal because just making sure that we are aware of traffic forwarding mechanisms and the way that the users are authenticated are very, very basic and important in order to be able to use the service much better. Otherwise, we might be having unexpected behaviors and not understanding why, because the way of the traffic is hitting into the cloud. So for authentication frequency, we can have daily only once per session, or a custom value from 1 to 180 days. This it's only valid for cookie-based authentication, and the client connector won't be using these authentication frequency settings. So as we saw before, we have two cookies, the cookie that's going to gateway and the one that's going to the specific site. The authentication cookie, it's on valid for gateway, and it's cleared when the user logs out. The domain cookie will be preventing the redirection for each access and only valid until the session is terminated. The SMEs will create a encryption key every 12 hours to decrypt the authentication frequency cookie for a daily authentication. And if the cookie is valid within that 24-hour time frame of the two cookies, I'm sorry, of the two keys, then the user won't be challenged for authentication. Basically, if we pass through that 24-hour time frame, the user will be challenged for authentication. With custom authentication frequency, we can set our own value. And once again, we can look for a specific cookie, in this case, the EXT cookie, that will show us the specific expiration time. The one that's only once, we also saw that one in a couple of examples. In this case, it's a little bit old because this one is showing 2023, right? And meaning that this header trace is from 2021. With the once per session cookie, the cookie has no validity time frame because it's cleared after the session or after the browser is closed. Now for admin authentication, we have to add the administrators manually into the portal. We'll go into administration management, and we can create or add the details for our admins. We can also have the default time frame for the password expiration, where it can be between 15 and 365 days. We do support SAML for this authentication method, and it's for also IDP initiated SAML. All right. Well, we won't be having that break right now, but I guess I'll be letting you guys go 10 minutes earlier so we can close out the session in this topic. Once again, tomorrow we'll be going through a little bit more with the creation of the users and the overall IDP integration. If you want to explore a little bit on that part, there is a file on the help documentation that basically takes you in through a step-by-step process of the Okta deployment for everything, administrators, users, for CIA and for CPA. Although it's already a couple of years old already, well, it's actually just, it seems to be updated now. Great. So it's basically a very, very good source of this step-by-step configuration. It doesn't take certain things into consideration, like the users repository or the database where we're going to be getting this. So we need to create it manually in Okta. But we'll be going through everything of that part step by step by tomorrow's session. For now, all I have to say, team, is thank you so very much for going through every exercise and task, for your attention during the day. And I hope this session it's been helpful and you guys are feeling more comfortable overall CIA. Thank you so much. Have a good rest of your day or evening, and I'll see you all tomorrow. Have a good one.
Thank you.
Thank you.
Thank you. Bye.
Yeah.
All right, team, just double checking. No questions, anything there? All good? Okay, team, hope everything is all right. And see you tomorrow. Have a good one.